Wait, why can't I see it?
Are we live? Okay, wait. Okay, we are live, I guess. I trust you. Uh, Hello everyone. Today we're going to solve EGMO TST Livesolve, as you can see from the title. Uh, we have Mandar in one wording, very old person. We have Athara Sutar, one another in one wording, very old person. We have Devat, another old person, and we have me. Somehow me also is there.
Oh, versus of us. Now let's go.
Wait.
Yes.
Okay. Yeah. Fine. Uh, Fine. Okay. So we will start with the first question. So this is like if you guys want to see day one and day two, and let's start with first question. No more introduction. Okay. It will be a smallest indication that with sign. This can be in any order, and this is like very ordered.
Yeah.
So we can just like take like permutation of this and add all of them. And we get another bound. So
Yes.
that was my first idea.
In time.
The only condition for non-disparate polygon is that a1 plus blah 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 plus an
Yeah.
is less than equal to, sorry, greater than equal to n.
Greater than equal for any side, yeah.
Yes.
So by rearranging the inequality, we can like maximize this, I think, by just
Can you? Okay.
Yeah, that makes sense.
Why can't we just start with n equals 3 and just check what m is in that case?
yeah, sure. M plus a1 squared plus a2 squared plus a3 squared is greater than equal to
So horrible.
2a1 plus 4a2 plus 8a3. And here we're assuming that a1 less than equal to a2 less than equal to a3, right?
Yes.
Yes.
We can just like complete the square here.
Okay.
We can
Yes.
add constants and form squares actually, yes.
Two,
It's
two
like
squared plus 8 3 minus 4 squared is at least 16 plus 4 plus 1, right?
Okay, but this is like not true because like we have a3 is greater than a2 plus a1.
Right. And we will have that in general, right? Because of like sum of things.
Yeah.
Okay.
Okay.
Wait, what if we just set everything to be like 1? What value of m do we get? M is at least 11.
Yeah.
Okay, yeah.
64, 32, 16. Oh, this is just obviously true. Okay, so we need to look at like small values. 4 plus 8 plus 16, 12, 16. Oh, we can get it down by 16.
How you get 16? You took everything as 2.
2, everything, taking everything 2 works for 16. Taking everything 4, 8, 16, 32, and 48. Oh, that actually gives you a worse round. So something between 2 and 4, the 3.
You're basically doing this, right?
Yeah, I'm just putting everything equal. Oh, right, we can just find the maximum of this at this place,
Yeah.
right? Okay,
yeah.
so I think we use something like this thing. So the maximum is at 7, apparently, right? It should be at a equal to 7, yes. 49. What?
Really?
No. Wait,
Here,
I'm surely coping. Okay, there is a factor of 3 which I forgot.
there's a factor of 3.
Yeah.
Yeah.
So maximum at 7 by 3. So 49 by 3.
Wait,
Okay.
how do you get this thing like m plus 3a square greater than equal to 14a?
Oh, you just put
Like,
everything to be like
in-
equal. Just take the equilateral case, polygon,
Yes, yes.
regular polygon.
Hmm.
Not coping on calculation, right? No, I'm not.
Yeah,
wait,
M3 is right.
yes, this is like even at least this, which comes out like this, at least
14,
49,
yeah,
right?
it's at least 49 by 3. Yes.
I think that should be the answer. I feel like. But how we
No,
do?
I feel like we can do better than this, surely.
Ah,
Like 49 is just a bad number. Like, it's not a good number.
Okay, 14.
Okay,
What
so
if
like
you
the
put
bound is
everything
between like
equal in this?
49 by 3 and 21.
Okay, what shall we put it equal to?
Wait, why is it upper bounded by 21?
Because like if you consider general ABC, then like it's upper bounded by 21, right?
No, sorry, I did not catch that.
oh, this one.
Yes. Yeah, this.
This is greater than equal to 0. So m
Oh,
plus something is,
yeah, it's strictly less than 21. Okay,
yeah,
sure.
strictly less.
Wait, we should be able to achieve values arbitrarily close to 21, though, right? Like
Uh,
just making
no,
things
but like this
close
this
to this.
this won't go to 0. Like
No,
this is
no,
like
like we
not in.
should be like, wait.
Okay, wait.
Okay,
Makes
no,
sense. Like
take
if you put
A1
both of
equal
them.
to, no, yeah, it can't go to 0, right?
Wait, we can get arbitrarily close to 20.
Yeah, we
Because
can
like
get
put this,
arbitrarily close to 20, yes.
How are you getting close to 20?
Oh,
like put
because take
1
A1
equal to,
equal to 1, A2 equal to 2, and take 3 approaching 3, A3 approaching 3 from the left.
Okay, yeah.
So
yeah.
that it gives you values arbitrarily close. Yeah, this seems like a much, much better way to work.
But you want smallest bounds.
Okay, so wait, what is a general bound for this case?
Like we take I equals 2 to the I, not 2
If
times,
we,
like 2 to the I minus 1, and you take an is equal to.
No, you just take it to be 2 to the. Oh, yeah,
No,
2 to the. Yeah,
n
yeah,
minus
it's minus 1, yes.
oh,
This thing, approaching this from like, the negative, yeah. Oh, yeah, you can. No, you can't take it to be 3. Like,
Okay, you
okay,
can't take
sure.
it to the equal, but you can like.
you can't
Yeah,
take
but
this, but like,
roughly this, like,
yeah,
yeah.
limits.
Wait, so what bound does it give us? 1 plus 4,
Okay,
16,
this,
4 to the
N minus.
n minus 1, right?
Oh, n minus
yeah.
2, right?
N minus 2?
What?
Yeah, like
Yeah, n
AI is
minus
2 to the I minus 1.
2,
So
yes, n minus 2, yes. So, okay, GP, I
plus.
remember formulas. Wait, why are you adding this factor?
We're checking the bound.
Aren't we just looking at this number right now?
Oh, okay, okay.
Oh,
And then
okay.
you just add a 1. Sorry, subtract a 1.
Subtract the 1. Wait, not 1. Okay, 1. Okay.
Okay, so that is just this GP, right? If
But
I'm
do
not
we
wrong.
subtract 1 always? Okay, yeah, so true. Yeah, this is GP, like,
Yeah,
you can
we can
calculate.
like.
You can calculate
Okay, no,
it.
just like start it from the first one because that is neater to write. So 1 by 3 times 4 raised to the power n minus 1.
N minus 1
Number of
minus.
terms is n minus 1, so it's n, this thing, minus 1. Like, okay,
Yeah,
this
it's
is a.
a number of terms. Wait, it's number of terms minus 1. So it should be N minus 1 minus 1.
Wait, number of terms is. No, it's number of terms plus 1.
Then you just substitute n equals 3, no? Like that gives 21 or 20 for m equals, for n equals 3. So I think this is fine.
This is
It is
Oh,
fine.
just.
it's n. Yeah, it's just n, right? Because like it's number of terms plus 1 and the number of terms is n minus 1.
Yeah.
So this is a value of m, and I'm pretty sure we can't do better than this because
Okay.
of this argument. No, okay, m is at least this one.
Yeah, M is at least. No, M is upper bounded by this.
A lower bound.
No. You can achieve equality, right? Because like suppose it isn't, then you can take a
No,
construction
but
of
like
this sort.
M is upper bounded by this, na? Like according to our
No, it is lower
figure.
bounded by this. It is
It
upper
is lower
bounded by
bounded by this.
this plus 1, right?
Yeah, it's upper bounded by this plus one, yes. In
Okay,
fact, strict bounding. Because like you can take any number approaching it, so you can like get in an arbitrarily close radius to this guy, but then you are cooked because of the like, thing. So minus one.
oh, I see.
Yes. So m has to be at least this number.
And it is at most 4 to the minus 1 by 3.
Yes.
We're basically done with the problem.
Wait, we are? How?
It's only like one difference. Just
Wait, how are we done? I don't get it.
Yeah,
no, we're
like
like
one more.
almost.
Wait, this bound you got from like what's that? This bound.
This you get by the completing the
The
square thing.
Oh yeah, you just like set everything to be equal, but that's a degenerate case, so we don't count.
Yeah.
Wait,
exactly
if
that
we
gets you
allow
degenerate.
degenerate polygons, will bad stuff happen?
Wait, what do you mean degenerate polygons? All side equal is fine, right?
Look, everything on a line.
No.
If it is, okay, no, I'm not
What?
allowing that. I know it's not allowed is a problem, but if we do that, like,
Then we can just get the 4n minus 1 by 3. Right?
can we always get that?
I mean, yeah, by completing the square.
Oh, right, that is true. Yes, that makes sense. Yes.
Logic seems to be like
Wait, are we done with the problem?
No, we're not done. Like,
Yeah, we have a bound and we need to show that it's at most this. Wait, so we want to show that m is at most this number now, right?
yeah.
yeah.
Okay. Wait.
Okay, how do you do this for m equals not n equals 3?
Yeah, it's a good question. Oh, this is actually always an integer, which is very
Yes.
okay.
Crazy. Was it integer? Like, no.
Wait, so m equals to n equals 3, we want to show that m is at most 20.
You take a n cycles and then you get each coordinates and then
We basically want to show that 20 plus a squared plus b squared plus c squared is greater than equal to
All
2a
numbers.
plus.
damn. Now we substitute Ravi. We do
No,
Ravi
no, no.
substitution. And
Oh, yeah, we can do Ravi substitution.
Wait, won't Ravi
But
like okay. Won't that be horrible?
wait,
No, it will be
wait.
fine.
Can we do Ravi for like general n polygon?
I think we
Is
can,
it?
right? No, wait.
No, you will need a like incentric or whatever quadrilateral for that. By like, polygon. So not really.
Um,
No, but we can do something similar to Ravi substitution. Like,
we just need a inequality like that. Yeah.
yeah, we
We
have a
don't
plus
need
b
a.
is greater than equal to c. So, like, well, we take a equals x plus y, b equals y plus z, and c equals z plus x, right?
We can
Yeah.
just yeah.
No, but this is because we have the incircle. Like if we don't have a general poly thing, so we can't do this.
Mm,
True.
Wait, we have like 2A, 4B, 8C. We should be able to Cauchy this somehow.
Yeah,
oh,
let's just do the
this,
Ravi.
wait, yeah.
It will work out.
Wait, Kochi, wait. How can you Kochi this? Kochi seems better idea.
I don't know. Let's see.
You multiply it by what was Kochi again? It is
Exactly.
something like some
Wait, 10x, I think. 10x
something
plus
2
y,
plus 16 plus 12
6y
is
plus
something.
12z.
This has to be trivial.
Yeah. But I still think it is like not this and just Cauchy somehow. Let's see.
You can now just complete the square and hope to God that this works.
How are you going
I
to complete the
agree.
square though?
Oh, You can't even do that. Okay.
Wait, you can, right?
It's a
Oh,
bad
wait,
question.
this just rearranges to the fact a minus 1 whole square plus b minus 2 whole square plus c minus 4 whole square
Yeah,
is greater or equal 0.
It does not rearrange to that. It
not zero.
rearranges to, I think, 1.
Oh, 1. Yes.
1 plus
What?
2 plus
Yeah,
6
because
squared.
21 was 0, right?
Oh, right. So we get a deficit of
What?
1. So this
Oh,
thing
so
is at
and
least. Wait, so we need this thing is at least 1 whenever like A, B, C are good. Like non-degenerate polygon sides.
wait, that should be somewhat good.
Wait, I think you can catch this. Like, this is easier to do somehow.
Wait, how will you copy that?
Like, one side you have squares, right?
No, but like how will you use the fact that it's like
Inside the thing.
yeah, sides of a non-degenerate polygon? How will you use that fact?
Oh, you kind of equate the number like constant, then what you do?
Wait.
Uh,
Yes, that's the point. Like, what if c equal to a plus b?
Yes, yes.
so you multiply by 4 to 1, and then you get like 4a plus some stuff, and you want this to be greater than. Okay, wait. Let's set somehow.
Like, if we have to do it for n case, like for 3 case, we should not use Ravi or something. That is like too
Yeah,
general.
exactly. Because
Can we like make kind of general form for
no, Ravi comes from like in circle, right?
No, not exactly Ravi, but like you have this condition, right? That the size are increasing.
Yes.
So you can probably like say something like A1 is X, then A2 is like X plus Y, and so on. I don't know.
Oh, interesting. Okay. Ah, yes, you could make that, but you wouldn't get a cyclic inequality.
Yeah, that's the problem.
Yes.
Won't get a second. I mean, hmm. I think we need to use the fact that we can choose a like A as in our term. Like, yes, we can do the cyclic rotations, right? And we get something like this. M times M plus n times sum of squares.
Should we not have strict inequality over here? I guess we
Yes,
should.
it's
No, right. Why would you have strict
We
squares.
do have
inequality?
inequality.
Because we are taking like the last side is approaching 3.
Oh, okay, yeah, yeah, it's a strict inequality.
But
Yes.
still, like, how are you going to prove that?
Yeah. Wait. We want to prove this thing in general holds. Is probably doing no minus one. Okay. Plus summation ai squared is at least. Wait, is this statement not just okay? No, we have the one. Okay, that is the issue. It's not right. Okay. It's 2 to the I AI. Oh, also like we have like greatest in oh yeah, we have the increasing greatest. Makes sense. Uh,
Fact.
it can't be. The poly doesn't work. Wait, how will we even prove that M is okay? We have to prove this inequality, right? If it rearranges to that inequality. So okay, what if we rearrange
Are you
this to
sure? I'm sure like this will be the actual the lower bound.
I mean, it's at least this much. There is like nothing less than this will work. We know.
Yeah, like this is
Can we smoothen this?
What?
Can we smoothen this? Like we have this thing and we know that y is less than equal to x is less than equal to z, right?
Yeah.
oh my god.
So if we like keep z constant and we vary x and y, I think we can say something about that.
Okay. But like even if you have this, like you won't be able to generalize this. So I don't know.
But smoothing could work in general.
Yeah, that is true. Okay.
What can you do with smoothing? So like we can
Wait, this rearranges to this guy. Moves 1 by 3, 4 and -1 -1. Uh,
so, so wait, yes, square. Okay, never mind.
oh, wait, what if we look at this as like a, what do you call it? This is a GM of some sorts.
GM of what?
It's like
Yes.
a, wait, so if we, I mean, see, this is a product of terms. What if we AMGM now? And the
That
equality
works.
will hold whenever, like, in that case, we can show that a strict inequality holds, right?
Yeah, we just
Because,
not apply them for last term kind of.
what?
Like we will like just not apply MGM for one term or something like that sort. Because
Yeah,
we
yeah.
can't apply
Okay,
to all of them.
wait. We can say that 2 to the I minus AI times AI is at most 2
Two
to the
times
I
S
minus AI plus AI divided by 2 whole square,
Yeah,
square.
so true.
which is just like 2 to the
2 I
2i.
minus
Okay.
4 to the I.
minus 2.
Oh, right, sorry, there's a minus
4
2.
to the I minus 1.
And then we can just like write 4 to the I minus 1, right? Not 2.
Yeah.
Okay.
Then we
And
need to add stuff up. But this won't
Wait,
give
no,
us
no,
this
no.
bound,
This
right?
gives
That
us
is cooked.
this gives us 1 by 3, 4 and minus 1.
but equality
Right.
does not hold.
Yeah. Also, we are not using the fact that like an is less than a1 plus
Um,
Right, we are not using that fact. Right. Hmm.
this-
Like if you have to show m is like the least bound, like 1 by 3 times 4 to the power n minus 1, can't we just, aren't we just done if we show this thing?
yeah.
Yeah, but like, okay, wait.
Yeah, that thing is like kind of we want to think we want. For general polygon and polygon.
Hmm.
Okay, wait, what is okay, wait, we don't exactly get that sum, right? Because we also have like half and stuff in here, right?
Which one?
Half
Okay.
squared plus 1 squared plus 1 to n. Wait, I can't possibly be going from 1 to n. I am going from 1 to n. It's like 1, 2, dot, 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 4n minus 1. Yeah, this is bad.
Why are we coping on P?
Hi, we're not coping.
Algebra.
This is like inequalities. It's okay. I can't inequality either way. Uh, Okay, is there a way to relate like powers of 2 and like use this criteria? Okay, what if I just look at this sum? Can I say anything about this sum itself? 2 to the I minus ai. Can I say like it will be positive, negative, or anything?
If you like, I
You
mean,
can
that's
make it
such a
that
like
will be,
question. Like you can take AI to be very large, then this will become
yeah,
very
exactly.
Oh, right,
big.
it will be anything. So
But like if you take
just
AI
bad.
equal to like just two, then like or very small also you can get positive. And this is like very weird. Like it's not homogeneous or something. Like
Yeah, yeah, yeah. It's scuffed stuff.
very scuffed.
Extremely scuffed stuff.
I was thinking on this like take sides as like 1, 2, 4, and like what is it? 2 to the power I minus 1 and 2 to the
Yeah.
power I minus 1.
Okay. Then
But that the equality hold, right? Oh, I mean minus epsilon. And epsilon is
yeah,
greater than 0.
Here's an idea. Um,
Oh, shit.
yeah.
you take like you know that an is the largest, right?
A and yeah, it is.
So we also know that an can be like anything in this range. Like an minus one is less than equal to an is less than equal to sigma an 1 to n minus 1.
That is true. Yes.
Yeah,
So
yeah.
can we show that like as an goes can we prove that an has to be equal to this like less?
Oh, okay. Kind of smoothing.
Yeah,
Oh, so just a smoothing argument.
I think
Interesting.
that's what we want to use. Uh,
because if we prove this, then we're basically like nearly done.
if we increase an
So like what would that look like? Oh, we want
square, yeah,
m plus uh, sigma ai squared from 1 to n minus 1 plus an squared is greater than equal to sigma 2 to the
mm,
a this plus
plus
2 to the n an. So we basically want the maximum of
Wait,
this is
how
going
did
to
you
max
get this one?
like
sorry.
this.
Wait, sorry, how did you get this?
No, like I'm basically like treating the a1 to an minus 1 terms as constant.
Okay,
So you want the maximum value of this, right? Sorry, the minimum value of this.
minimum value of this. So that will be just when like an approaches 2 to the n.
Okay, like clearly, as AI decreases, the value of this thing also decreases. So like an has to be equal to the sum of the rest, right?
Yeah, I mean
Yeah,
approaching the sum of the rest. Yes.
Unless like, yeah, yeah, okay. So
like
then we
if
Then
want
an is like more than 2 to power n, then this will decrease, right?
no, but like we
That's
don't
what
want
we.
this negative any trust.
Ah, okay, okay, I do.
I do.
Wait, hang on, does this work?
No, no, wait.
Wait, it's inequality. Okay, what is inequality? Like, what is a trivial inequality? Surely it is something trivial we are missing. Yeah. Okay, wait. When does the equality hold? Like, okay, rough equality.
Never, I guess.
Okay, what if we look at these terms? A1 minus 1, A2 minus 2, dot dot dot, AN minus 1 minus 2 to the n minus 1, and AN minus 2 to the n. What if we like try to phrase the problem in these in terms of these instead? Because those are the terms we
What
are
if one
working
of
on.
them are like in negative?
Yeah, but we have the squares
Like
of
what?
them. It is not an issue.
Like don't talk about the negative case. I don't know, probably just that. Don't talk about the negative case.
Okay.
Like at least let's just try to rephrase them. It's okay if they are negative.
I
Let's try
mean,
to rephrase them at
okay,
least.
if you call like bi equal
Okay,
to this,
yeah, like this will be okay. Rephrase this there too.
You can give bounds on each of them, right? Because it
call
can't be
again.
too far apart from 2 to the power n minus, or 2 to the power I basically. Otherwise, it will be greater than 1.
Oh no, yeah, but this is only true if you take okay, Bn you need to define differently. Bn will be like this thing because we know that it does not approach it. Like it's strictly less than this number. If we take all of them approaching 2 to the I, this guy will be strictly less than 2 to the n minus 1. Right?
Yes.
That's theory logic. Okay.
No, I mean it's not. Like I mean I just want to
Yeah,
model
I
the
got
case where the equality holds.
yeah, I got it. Right. Okay.
Yeah.
Then we get like this is true for I equal to 1 and minus 1 and minus
Okay, what is AI?
the AI. Okay, you can define AI as a bi plus 2 to the power I.
Yeah,
Like that.
right. Let's just write that instead. Bi 2 to the power I minus 1 bi
Okay.
summation over this. Wait, first we have like bounds on the sum of. This is not good. This is not good. Wait, we don't have BIs, do we? Okay, we do have BIs. No.
We want to prove
Wait, we
that.
don't have BIs. Wait. We don't have BIs.
Hang on. All we want to prove is that this is true, right?
Yes. Like
Uh,
induction.
Yeah.
Yeah, so
no.
what we can do is we can like bound every AI, right? Like we can say that 0 less than a1 less than 2 because like we know that a1 minus 1 squared, like assume this is false for the sake of contradiction. So
Oh.
then we have the sum of all of this is less than 1.
Okay. Okay. Now.
Oh, right.
Okay.
So we can
Wait.
just
So
bound
that
those
that's
AI.
yeah. That
Wait, the
gives
sum of
this.
them has to surely be bounded, right? The sum of them is just the sum. Okay, it is just like an minus summation I equaling 1 to n minus 1 minus 1. And this can be arbitrarily close. So it's like upper bounded by minus 1. Is it a minus 1? Or no, it's a plus 1. Okay. So it's upper bounded by plus 1. Oh, now we just like RMS, right? Like this sum.
Yeah. Yeah. Okay.
It's like,
Okay.
no, you get 1 by n. No. Yeah, 1 by n square, I think. Yeah, you get like this sum is at least 1 by n. That is useless. Sorry. Wait, no, I think I calculated it.
If we take like small enough n,
No, my point is like, okay, wait, first can we argue that like all of these interior terms we can force them to be positive?
yeah. Also, we can argue this like this gives nice thing like we are kind of upper bounded for each side.
Yeah, exactly. So all of these terms are like positive. That is why AMGM works, and that is why it's at least like 1 by n. At
Okay.
least like 1 by n. Yeah,
Wait.
it's at least 1 by n. This sum
Oh,
is at
okay.
least 1 by n.
Yes. That I got. Okay.
Yeah.
And now it's three. Acha, okay. That's
Okay.
It's
great.
plus 1 and minus 1 of the power of 2.
Yeah. No, I was saying like, can we add like all of this upper bound and lower bound and we somehow get some like
Yeah.
that?
Okay, now we can use the earlier equality, right? Like we showed that if an is greater than equal to 2 to the n, then increasing an is beneficial. Like increasing n gives a worst case.
Yes. Yes.
Yeah, so what we can say is like, hang on, let me think about this.
Wait, does this not just work? Oh, you wrote this wrong.
No.
Yes, it's actually you have a 2 to the I here. And like in our definitions, we have an I minus 1. So it rearranges to this very nicely. Like you should be able to bound the sum of. Oh, this is okay. This is analogous to what Freddy is doing. Yes.
Yes.
We have like two approaches in same way.
Yes. So we need
Which
to
are
show
identical.
that this is at least this thing. Or 1 is at least at most summation bi squared. Oh, that is
Yeah.
okay. Yeah, like that is what we want to prove. Okay.
So true. We already get bound on AN, right? Like we already know it's less than 2 for AN.
Yes.
Okay, and if we take like Q minus 1, we have I. That doesn't look nice for me to take an N. If you get like 2 to the power 0 till 2 to the power N minus 1, the N minus.
Wait, why are you forcing these upper bounds?
Because we know that an
Oh, you are
minus
okay. Yeah, sure, makes sense.
yeah.
Wait, is M for like all of. Wait. What is the question? The smallest real M such that this is an N. Okay, it is for a general N, right?
Yeah.
Yeah,
Which in we know that it's okay. Wait. We know that this we
we
can
just
make
need
this
to.
approach one, right? We can just make this approach one. That is just true. Like we know that this is at least 1 over N, and we can make it approach 1.
How?
Because
Uh,
you take equality on the first N guys, N minus 1 guys, and then like the sum of those is 2 to the like okay, it's the next guy minus 1, and then you take the sum approaching that from below, like the last term approaching that from below. Wait, does that not just work?
Could you like explain it for like 3 variables?
Wait, let me write it down better, then I will be able. To 2i minus summation bi squared summation bi squared summation.
oh my god, just 40 minutes past.
Yeah. Okay, this does not work, right?
What does that look? Yeah.
Oh, sorry, was muted. Atharva, did your strategy work?
We don't know.
Okay. Like I was also trying something. Like, if we have the n gone and we choose one like diagonal conveniently such that this sum is like the increase is positive, then we can go then we can be done also.
Like you're inducting.
Yes. And I have to choose bn minus 1 carefully such that like it is what to say, acute or obtuse, something like that.
This is equality.
Hang on, can you explain the full induction?
Like Okay, so I have this main n convex thing.
Oh, okay.
I'm like taking this side and taking this new sequence b1, b2 up till bn minus 1. So the new sum, that is this thing, right? I originally had this thing. So I'm like decreasing this thing and then I'm adding these two. So like I worked it out, but there are some terms which I can't show like they're greater than 0. Yeah, my work is a bit untidy. Sorry.
Minus 1 minus an.
You don't want that to positive and then like.
Okay, yeah, okay. See, this works, right? Freddy Ohm division. See, so we define those BIs. Now the product, it just redefines as it's actually okay. No, don't care about this right now. We have this terms here. Okay, where did they go? Yeah,
Yeah.
these guys, right? These guys.
Yes.
This term can be written as summation 2 to the I minus 1 minus bi 2 to the I
Okay.
plus 1 plus bi. This is the AI term and this is the
Okay.
2i minus AI term.
Yeah.
Okay. Now you can write
Yes.
this one as summation 4 to the I minus bi square, which is like summation 4 to the I minus
What?
bi square summation bi square. Uh, and okay, my chain malfunction. That's sad. Now we have like, see, summation bi is equal to ai minus 1 plus a2 minus 2 dot 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 a n minus no an minus 1 by what is
To the
this?
power n.
Wait, let me get my pen. Yeah,
Power.
an minus 1 2 to the power n minus 1 plus 2 to the power n minus an, right? So this we write a1 an minus 1 minus an, and the sum of these guys is just like negative 2 to the n plus 1, which cancels. So this,
1.
and then we know that this can be like approaching 0. So we write that this is strictly larger than 1. Okay.
Okay. Yes.
Next, we use like the Freddy argument to show that all of them are positive, like none of them are negative. We use Freddy's
Positive.
argument to show that none of them are negative. And then okay, no, I just like wanted to show on that was. Now we just come back and we look at this. Now we apply RMS. So we get BI by N. And this is strictly larger than
Oh.
1 by N square. We can cancel this. So we get that M, which was
Large.
strictly larger than this quantity, which is strictly larger than this quantity, which is strictly larger than this quantity, which is strictly larger than this quantity, is actually larger than summation 4i minus 1 over n. So just taking n approaching infinity, you just get like, okay, no, this is false.
Sir, you said like this is larger than this, but then you have like negative. Yes, yes.
What?
Right. We have negative
No, we
BS
can
square. We
use
get this.
Freddy's argument to show that like BIs are not right.
No, I'm saying like you get this thing.
How are you using the argument though? Like, why
Oh,
can't you?
because wait, you said that like all of these lie here,
Yeah, but
so I can
showing that the
subtract
absolute value is like the absolute value is 1.
the absolute what?
The absolute value of bi is like less than, sorry, the absolute value of ai minus 2 to the I is like 1, less than 1.
Okay, then we use RMS on the absolute values.
I mean, yeah, essentially just putting it like BS are greater than 1, 0 is okay, I guess. Except for A1, but A1 can be managed, I guess. So
Okay, no, I just think this is false now. Missing a factor of 1 something. Use mod BIs. Oh, I can't do that.
Should we try Dabarchan's induction?
Yeah, we can.
Wait, I did not get far with that. Maybe you can.
It's like basically what we can split it into this kind of thing, right?
Yeah. Then
Yeah.
you assume it for n-1.
Yeah, I think we have to assume for n-2 here because like we're removing two sides and adding for the new. So what was
Yes.
m, the value of m again?
It was like summation 1 by 3 times 4 to the n minus 1 minus 1.
Oh, like this.
No, there is nothing here and
Oh, okay, okay. So we want this to hold,
yeah.
and we can assume that we can take that. Sorry, we want this to hold. Substitute this here. So we can assume that I n minus 2, sorry, 1 to n minus 2 sigma ai squared is like,
Wait, is our answer wrong? Like, are we sure this is correct?
I think so.
When does we get like equality?
I don't think we ever get equality. I think like it should be in general, like for the nth case, it should be this.
Or like m equal to like
Okay, at least that is
1
what my
minus 1
bound
by
is.
3. I mean
That
like
much
not
should be.
equality, not equality, but I mean like can we even like approach very close to this bound like with like some numbers? And we are pretty sure like this is the bound, right?
Yeah.
Right
Wait, so the
answer.
number is 1 over n, 1 over 3, 4 to the n, minus 1, minus 1 over n. Is equality hold. Use
Okay, that's
all of these to be roughly 0. So shrinking it by epsilon should just work out. Feel like okay, tweaking all the BIs by epsilon should work out. Equal to over 1 over half. What are we? Wait, is someone looking at the chat if the chat is saying something? Or is it just there?
Yeah, look.
Oh, you can't look your screen sharing.
I can't. Yeah.
Yeah, look at your phone or something then.
I think we should move on. Like, let's just come back this after doing tomorrow. We basically put like 50 minutes in one problem. It's like pico.
Yeah, that is true. That is true. Wait, but I'm pretty
No
sure
one
that
ever
is
said
like
that.
this is the general answer. I don't think our answer is correct from before. We can do
Yeah,
better than that.
correct.
Because
And
like
since
my
like
bound shows this, so I just need to
we
find
can,
that function which works.
yes. Uh,
Wait, so
so
I
this is what
want
the
it to be extremely close to be this.
No, I think it is correct because what you're trying is you're taking n to infinity, right? But that is just increasing the value.
Yeah, that is what I was saying. Like, I think, okay, but we need to find a counterexample for everything that does not work.
Okay.
So we need to backtrack now. I think
Oh.
summation bi, which when bi's are equal. So, okay, that was bad. This just translates to summation bi square.
No, I think I'm done. Oh,
Wait, you're
you do
done.
this induction.
yeah, induction. Okay,
Okay.
just check my. Oh, so we're first claiming that like the induction hypothesis is that like m equals this quantity.
Wait, I'm pretty sure this is not accurate now. Okay, but sorry, go on. Yes, go on.
Okay, so yeah, you just like I think you can. I took n minus 2 for no reason. I think you can make this work with n minus 1 as well.
Okay, sure.
So you substitute m as 4n minus 1 by 3 minus 1. You want to prove this is true.
Okay.
And now by the inductive hypothesis, again, we can uh, consider the n minus 2 case. So we can say that uh, n minus 2, like sigma, this quantity,
Yeah.
this is less than equal to 4n minus 2 minus 1 by 3, right? Minus 1.
But does it form a convex like polygon?
Yes.
Yeah, it should.
Okay.
Right.
Okay, wait, no, it doesn't have to.
Yeah, like in our counter example, like in our example only where we were taking a till a n minus 1 as to the power n minus 2. In that case, I don't think.
Yeah, yeah, yeah.
Wait. Why it can't? Wait. What do you mean? Like, if we have like convex polygon with ends, right? You just take like this thing, right? And this still form a convex polygon.
No, like,
But you're not taking into account this side in the
yeah,
induct.
so we have to take out that's it in some,
Yes.
Oh.
like, but,
Okay. Um, can that side be like close to like zero? No, right? That doesn't work. we move on, I guess.
Oh, wait, the equality just occurs at a point. Okay. Wait, it should be this, I think.
What?
Because then you can take all of the BIs to be like 1 over n and like take the last guy a little. Yeah, I think. Wait,
No,
see,
okay.
we get like this bound, we get m is at least this thing. And for anything that is less than this guy, we can take all of the BIs equal to this. So the equality here would hold. Okay, we can't take all of them because we need to like follow triangle inequality. So take it to be like take the last guy or something to be 1 minus epsilon, like 1 by n minus epsilon. That will get it arbitrarily close to this thing. Yeah.
Okay.
Wait, does this not just work out? This just works, right? See. So does it like okay, do people get how we got this inequality?
See,
Yes.
I got okay, fine. See, I got till here. Then like how
Where?
you like jump from
Oh,
here to
yeah.
there.
Yes. See,
Like
so we know
we
that
have this,
summation
yeah,
bi is equal to
square.
this
No,
thing, right? So
I got this thing like bi square is
it's at
greater
least
than
one.
one.
Did you get that summation bi is at least one?
Yeah,
Now summation bi squared
it's at least one by
is at least summation like okay this thing by n, this thing squared, just there was a division by n here, bi, and then like this
yes.
thing is oh wait. Oh, right. See, we can write this as this so as to remove the trouble of the negative cases. Okay.
Hmm.
This is still true. And then this is at least now triangle inequality. Summation. No, this is like mod of summation bi over n, everything squared. And now mod summation bi is like at least one. We know that from here.
Yeah.
Yeah,
So this thing is strictly larger than 1 over n square. And
yes.
then this implies summation bi squared is strictly larger than 1 over n. Okay.
Okay.
Now we get that m is at most summation bi squared minus 1 over n. And I claim that you must take this value because otherwise you can take all of the bi's equal to 1 over n and the last bi to be like 1 over n plus minus epsilon. Just a second, I'll have to open the door and
Oh,
Yeah, that makes sense.
yeah, that makes sense.
Hmm.
okay, yeah. Does that make sense?
Right. Um, yeah.
Only one question here. What? Wait, did that make sense? Like, or is there some argument, like loss, like, problem in the argument?
Yeah, that makes sense.
Wait, so the answer is not actually minus one, right? It's like 1 over n.
Yeah.
Okay. That was
Yeah.
correct.
We missed some like equality. Yeah, we missed
Oh,
some
can I like
equality
summarize
case.
the solution for the stream?
Oh, we
Wait,
weren't.
this just work, right?
Yeah, I think this just works. Yeah. Okay. So
Yeah.
I think you should like explain the solution once.
Yeah.
Like we do now. Wait, who's explaining the solution?
Oh, you explained it.
Oh, okay. Sure. Then you people should start
You
P2.
explain that.
Wait.
I will
Oh,
just I will just follow you and just explain
yeah,
notes.
that's a good idea. Okay, Devarsan and
Yeah.
Atharv can start P2, like we'll just explain and get back.
Yeah, okay.
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 So wait, should I rewrite the entire
Like
solution or
Geo.
just explain from these ones?
Or just
I
explain like
think like we
key
should
idea.
not rewrite, like go over the like main points. and like because they already
I'll just write it on this side then. Okay.
these things, somewhat things you can rewrite.
So we define
Okay, sure.
bi equal to ai minus 2 to the I minus 1. No, just 2 to the I. And bn equal to 2 to the n minus an. Wait, we can't
Yes.
define it to be this. We need to be this actually, I think. I don't know. We'll figure out the details later. Okay, we define this. Now we have summation 2 raised to the power I minus ai times ai. Now ai can be, wait. Oh yeah, there is a minus 1 everywhere. Okay, that makes sense.
Yeah.
Now this
Uh,
can be written as 2 to the I minus ai is just
this is
bi. Yeah. Wait, so ai is just
yeah,
equal
what
to like bi plus 2 to the I minus 1, and this term is simply 2 to the I minus 1 minus bi. Yeah,
wait,
that is correct.
that
Yeah,
okay,
that
yeah,
is
okay,
this is correct. And then this
yeah,
is
this
an equality. Then we have summation 4 to the 2i minus, no, 4 to the I minus 1 minus summation bi squared, where we are taking appropriate limits so that everything works. Now, what we wish to do is bound this term. So observe that summation bi is equal to ai minus a1 minus 1 plus a2 minus 2, so until an minus 2 to the n minus 1, which after some algebra turns out to be this thing. This thing. Okay, there is a negative here. Nice. A positive here. an plus 1. And now, like, as it's a non-degenerate polygon, we will always have that
yeah,
this is positive, but it can approach 0. Like, it will approach 0, so we can say that this is greater than 1.
yeah.
Now we do more inequalities. Okay, I really don't like inequality problems, but I should not say that.
Mandala was
Summation.
equal to be in one.
No, I was in inequality. We don't say that. Okay,
You
so we get like this is just like AM RMS AM inequality. Wait, root mean square has another name. I think it's called the quadratic mean as well. So those who know it by
Hi,
that name can do
hi.
MAM.
It's
It's
just
okay, bro. Like we should
math.
be clear, okay? Like we should be precise and all.
It's just math. It's just math. Trust. It's just math.
Okay. Then we have
I
like
I checked last time.
a
It's just math.
triangle inequality. Then we like apply triangle inequality to get this thing squared, which is strictly larger than 1 over n squared. So that implies that summation bi squared is strictly larger than 1 over n. And now we take this thing and plug it into the top value, which implies that m is at least, okay, no, not m. We get that summation 2 to the I minus ai times ai is strictly less than, okay, it's less equal. Okay, not even, yeah, it's less
Okay.
equal. What was this thing called?
So
Summation 4 to the I minus 1 minus 1 over n. Now our claim is that this is the required value of m. Suppose that it is not, then you can take bi equal to 1 over n for all I strictly less than n, and then you can take bn equal to 1 over n plus epsilon. What this will do is like the equality case of AM RMS is that whenever everything is equal, and in this case it happens to be the 1 over n case, So we just tweak the last guy a little bit so that the inequality doesn't work and we are like strictly larger than it. So the entire sum will actually be strictly less than it. So like we'll get a contradiction because you'll get a value which is larger than the value which is smaller than m. Hence m is the smallest possible value. So like the general answer is actually 1 over 3, 4 to the n minus 1 minus 1 over n. This is the mn. Mn is the answer for the nth time. Yeah. I think that's it.
Yeah. So, like I just if you set everything else, then like last one by this does not like give us eventuality. I guess it should be n minus 1 by n, right? Something like that.
No. See, when you take all of the bi's to be 1 over n, you get that summation bi squared is equal to 1 over n.
Yes.
Okay.
Oh, so
But when
okay.
you
So to get like you add epsilon.
yeah, I add
And
epsilon,
it's
so the
like
summation value is larger than 1 over n. Then I'm subtracting something which is lesser than that,
yeah.
so I can like get arbitrarily close to it. The point is I can get the summation bi squared to be arbitrarily close to 1 over n.
Okay.
Yeah.
Okay, makes sense. Okay. Let's go on to P2.
Yes.
Next.
Yes.
Where are
We
you
should not
guys?
take longer than this for P2. Sorry.
Nah, it is Geo.
We,
Trust.
we might
Okay.
just we might just
So
we might just
that's good. Okay. Uh, D data says that's just harmonic chord. A is midpoint.
wait, that is harmonic? What? Oh right,
This
that
ratio
is
is
harmonic. Okay, yeah, I did not realize
yeah.
that. Yes, it is harmonic. Okay.
Okay. What?
Midpoint of DD dash. Okay, this is okay. Midpoint of DD dash, line through M perpendicular to BC. Sets AB we see at PQ. But APQD cyclic. Only if nice.
Okay, so this is 90.
Like I have a conjecture that
Power.
we show J, PD and N are always collinear, where N is the midpoint of AC. Then like we have this is always 90 minus C. So in that case, we'll always get the if and only if thing.
Oh, so you're claiming that PDN is collinear.
Yeah.
Now we're
Cool.
getting
You define. Okay, wait, why?
Wait, why should this be true by the way?
why is it 90 minus C?
Because if this is true, then we get this is always 90 minus C.
How?
And if
Like,
always
isn't that
Why
only if
like
isn't that
Wait,
only if
like this is
no,
only true
wait,
like
this
yes,
need not be 90,
either of
right?
this condition.
Need not be
yes.
90. That is false. This
We
need not
need
be.
this either of the condition.
Yeah, this will always be okay. That will always be 90 minutes. That is correct because this will be
No,
C.
no. So
So that will not
basically,
always,
like if you consider
that won't
this
always.
angle will be C, this angle will be C, but like we want like either like this 90.
Yes, yes.
Oh, okay, wait. Okay.
It won't always be.
So what we assume first, like, is cyclicity or like perpendicularity?
Let's assume perpendicularity. That seems easier to
Okay.
like. Just
Okay,
have
so
to
if we
show.
assume it's perpendicular.
Okay,
Okay,
let me
so
draw a
like this 90
diagram.
minus B, 90 minus B. So this is 90 minus B, this is also 90 minus B. So as you said, like if you consider Mn, those things
So we
comes
said P
collinear.
and N are collinear in that case. So this ratio should be
90 minus C, so it's C, okay. Those things are collinear. So we can intercept it midpoint. Do you want cyclicity? Never mind. Yeah.
APQD. Okay. APQD.
But how do we use this ratio condition?
Oh, that is cross ratio minus 1.
Yeah, but like how?
Like I don't know if products or something. You have midpoint, so it's likely power of point somewhere.
Yes. Okay.
We draw
Like
theta
basically,
plus
B and C are inverses with respect to the Apollonius, like circle centered at M with
Yeah.
radius MD. Okay.
Like MB MC is equal to MD squared.
Oh my God.
Can we rephrase the problem in terms of M?
M square.
Wait, it should hit the midpoint of the opposite side always, right?
Yes.
Wait,
Okay.
Not always, but when the conditions are
I mean,
satisfied.
when the condition is true, yes.
which condition?
This cross ratio condition.
Wait, like if cross sections are two, then it's like collinear. Like wait, which conditions you assuming first of all? Like
Like
perpendicularity, right?
perpendicular,
Yes,
yes.
yes.
Then like we get those midpoints are collinear. Like
Yeah,
Yes.
yes. Then it has to be that the collinearity holds.
interesting. I don't see.
Oh no, because see, this angle would be 90 minus C because like
Yeah.
right angle. And then if the cyclic thing holds, then this should be C.
Wait, like not we assume perpendicularity, so we have to assume one of them, right? Like
Yeah, we are assuming perpendicularity right now, so that has to be 90 minus C. Okay.
And this will become isosceles trapezoid basically.
wait, has to be 90 minus c. It's perpendicular.
Why? Because this is 90 and this is C. So in this triangle, that is 90 minus C if it is perpendicular. Even without
Okay.
perpendicularity, this holds. Like,
No,
leave
no,
that.
I thought this one. I thought this one. Yeah. Okay. Never mind.
Okay. Okay.
Okay.
Yeah. Then now you get like for the cyclicity to hold, this angle should be 90 plus C, this entire thing, for the
Yes.
cyclicity to hold.
Okay.
And this is 90, so this should be C.
We want it to be c. Yeah.
Yeah, we want it to be C, and then we want this angle to be C.
Yes.
But this is true when it's the midpoint case. Because like 90-degree
But,
isosceles circle thing, right?
but like, why P, D, N are collinear?
Oh no, it
In this,
should not, it isn't. But if it is, we are done. And it should be,
Acha,
like, for the
like,
problem to be.
like that. Acha,
Huh.
okay.
If it is true, then we are done. Yeah.
Okay, okay, okay. I got that. I was just confused why they are collinear. We got.
Hmm.
Hmm.
Wait, can we bash this somehow?
what? No, please.
Okay.
Why? What is this like? Like why? Why no bash? Sir? Bash good for health. Wait, we should be able to project some cross ratios.
Project this one there.
Which
We
one?
don't know their value. Why we don't know that's value.
Wait, we know the parallel thing holds. We know that much.
Yes.
Wait, if we assume the cyclicity. Okay, no, nothing. I understand. Makes sense. Okay, can we show that PD dash is parallel to AC? Then we'll be done.
What?
We want PD dash. Okay, we just want to show that PD dash is parallel to AC.
Okay, yes, yes.
That will finish the problem. Okay. This midpoint.
And where does that go? Okay.
Okay, wait.
Oh, okay, wait. This works.
What works?
Let where is it? Let F be this thing.
Put.
Feet
Okay.
of
Sure.
Okay. Now by harmonic thing we have BM into BC equal to BD into BD dash.
True.
Okay. And now by this cyclicity we also have this is equal to BF into BP. So we get what? D dash P D F cyclic. But we know this angle is angle C. So which gives us this is angle C. So which gives that's a parallel, and then we just use harmonic
Oh yeah.
from P
Okay.
to
Sure.
project D on the, and then
Okay.
we
That
get the
was.
cyclicity. And
Okay. Yeah. That just works. That was very clever.
and wait, and that just works for like the cyclicity just hold always.
Wait. How did you change BD dash is equal to this stick? How did you do that?
Because of this 90 degree angle PMC equal to angle PFC equal to 90.
PMC, PFC. Oh, similar triangles. Okay.
So it's 90 degree. What are we?
It's similar triangles, bhai, like similar triangles.
What is the 90 degree? What is similar triangle?
Are similar triangles. Superior.
No, no, I don't accept this.
So we are done in like one direction. We assume like
Okay, wait. It won't work nicely because now we don't have perpendicularity. But okay, cyclicity. Okay, cyclicity is the
Of
harder.
cyclicity. Okay, see, if we have cyclicity, this collinearity is not given.
If you have cyclicity, you have a lot of other stuff, right?
Wait, but we still have this cyclicity, right?
No, wait. Cyclicity
Okay,
we
no, we
given
assume.
like this is not 90, but we given that like these angles are like this is 90 minus C, and this is also 90 minus C.
Come on, can we
Yeah.
like draw a new diagram for this?
Yeah, I think we should
Wait,
draw.
if this is 90, wait, you don't have that this is 90 minus C, right?
No, we don't have it. What are you talking about?
Exactly. You do the.
Yeah. What are you talking about, Manda?
Wait. See, QP is parallel to AD, and we know that AQPD is cyclic, so it has to be an isosceles trapezium.
QP is parallel to AD. We don't know it's parallel to AD. AD is not
Oh,
perpendicular.
okay.
We passed those times. Now we are now new people.
Okay, now we know cyclic. Okay,
So
sure.
basically, PD and N are always collinear, right?
No, that is not true. That is not true because we don't know the perpendicular.
But using this, we get D dash P D F are always collinear. Sorry, concyclic.
No, that is if we assume the perpendicularity. Oh
Is
no,
it?
we did not assume perpendicularity, did we?
This is just like POP and from the ratio condition.
Yeah, exactly. So yeah, I think it.
We always see, right? So PD and N are always collinear. Yes.
Yeah.
What? Wait, what?
Like you
No,
said,
PDN can't be always collinear. No, they should not be always collinear.
no, but from here we get D dash P D and F are concyclic.
No,
That
we
is
only
true.
get because D is a theta perpendicular.
Oh yeah, because
That
we have the original cyclicity that AFDC is cyclic. Otherwise, we would not have it.
Oh yes,
no,
right.
like if will be still cyclic, but this angle won't be C.
Yes,
Yeah.
got it.
This angle not necessarily C. It's some random angle.
Yes.
I mean, okay, the cyclicity still hold, but this angle won't be C. Well, let's just move to new diagram. I guess.
Okay.
So like still the feet will work, but the angles are not nice. But you can still work out, I guess. Like,
Here we're assuming cyclicity, right?
Yeah.
but yeah.
I
So
think
we
that's
have this
proving that
90.
ADPQ is an isosceles trapezium.
Yes, that works.
Yeah, you are so right. Yes. Yes, we need this cyclicity. We might use it from different angle now.
And what is this angle?
Wait, how is this 90 minus C?
What is
Yes.
B?
Because of like this is 90
Cycles.
minus C.
Yeah, this is
Oh,
90.
okay. My
Yes.
This is B. This is B. Yeah.
yeah, 90
This
minus
angle is
C.
equal to that angle. Nice.
I draw such a beautiful handwriting, and you just
Yeah, yeah,
some
yeah.
big
Totally
numbers.
understandable. Totally understandable.
Yeah, exactly.
There's A, this. So we should be able to get this angle now, right? Wait. What?
Which angle? That angle? No,
I don't think.
Wait,
no.
you can because this is a straight line. And okay, we don't know
Oh,
that if this is a straight line. Okay.
yeah, exactly.
No, what if I define
You
it to be the
said
straight line
we
that
can.
intersects it? We
But then we
can
are
just
not.
define it to be the Okay, like let it not be a midpoint. Like
Okay,
let it
sure.
not be the midpoint. Then we know the angle. Suppose.
What is the angle? Oh,
I don't know. It's something hard. Like it's math calculations. Very hard. So it's like 90 plus A minus, no, 90 plus C minus A. What?
yeah. Yeah, this is 90 plus C minus A.
Wait, what is 90 plus 60?
Wait. It
No,
can't
no,
be
no.
90 plus C
You're getting
minus
wrong.
A.
This is not A. This is not A.
What
This
are you
whole angle.
guys cooking?
Bhai, okay, wait. Okay, I was coping. Okay, it's wrong.
Yeah.
Leave.
Okay, now you guys can do cook anything you want.
Yeah.
Okay, this cyclicity like make me like draw circumcircle very badly. But I don't want
Does
to.
not give us anything.
Wait, will D dash also lie on this? Let me show that. Is that
Did
true?
I lie on what? No, it won't
No.
because like this angle
Right.
is
Yeah. This is not 90.
yeah angle equal to 90 is very good claim to be have.
Yeah.
But if it why okay 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 need to do this quickly. We have this alpha again. Oh, wait, do we get some cyclicity? Intersect
Yeah.
this. No, need to intersect this with this too. Beautiful.
Bhai, what is this cyclicity? Don't cook this.
Yeah.
That's a
Yeah,
bad
man.
idea.
Okay, we need some similar kind of construction.
Yeah. Wait, can we get that cyclicity still, assuming the thing?
We get that cyclicity, but those angles are not nice. But we can introduce this point also. And now we can project harmonics. So we get like AC harmonic, which is quite not useful.
Wait, AC and what is harmonic?
ACNT.
Oh, okay, yes.
Can I project here and nothing happen?
Wait, won't this? Okay, this angle will be 90 minus alpha. Sure, doesn't matter.
That angle I can okay.
Wait, so this angle is B plus C plus alpha minus 90. Okay.
Oh, totally you can't write like uh, 90 minus A plus alpha.
No, obviously not. Who does that? That is no.
Yeah,
Too like
too much. to ask.
Exactly. No, that is, no one does that.
Yeah, too much to ask. I agree.
Exactly. How do we show such stuff as parallel? We can't get angles, so
You probably need feats. I don't know.
We
I
want to
mean,
show
let's
that
just
90
introduce
minus
the feed,
b
right?
minus
Let's
alpha,
just
right?
wait,
Wait,
what?
what?
We want to show this, right?
Yeah.
Yes.
So
No. Okay.
we basically want to show that 90 plus alpha is 180 minus b.
Yes.
So
Or
like here
alpha is
it is
90.
90 minus. Okay, wait, that is
Such a
Yeah, if we
great.
get that, we are done.
no, that's the
Wait,
same that we got earlier.
why have I screen? Okay.
Wait. Let me be watching Livesolve.
Hmm. So we get, if we introduce feet, then we get that cyclic. It's cyclic. What is that cyclic? We get something more about that cyclic. We get this angle. What is this angle? This is this angle
Please.
is
90 minus C. 90 plus C. C.
it's 90 minus B. Okay. 90 minus B plus this angle. Into 90. A. Again. You sure? I'm sure. Yeah. Mhm. 1 minus 2A. Okay. Oh my God. Oh my. Oh my.
What?
Oh my. Okay. What you do the same cook. So notice like this still cyclic, right?
Yes.
Yeah. Now you introduce this fit too. Okay, we already had it. And we get this cyclic. Okay. And now we use new color.
Like what cyclic?
ED D dash Q.
Okay. Yes.
And now
Wait,
we
how
have
do you
this.
get that cyclic? Wait. How do you get that
Yeah,
cyclic?
that's same logic as upper, right?
High what upper?
Why it's same.
Oh, that.
Huh?
Okay, you just power of point again. Okay.
I mean, I don't know. Like it should be PowerPoint. Trust. Wait, it's not.
Wait, it can't
Don't
be
trust.
power of point. Like, what will you power of point about?
Oh, it is okay. You PowerPoint from C. Ah, okay.
Ah, that
That's
is
be smart.
okay.
Yes.
Being smart is hard,
Yeah.
sir. Like, it's not easy.
Okay. Okay. Now we get this angle equal to 90
Oh,
minus
okay,
C
yeah.
plus R. And now we get this angle equal to 90 minus B uh, plus A minus alpha.
Okay, so
Just
you just
okay. Wait.
equate them.
I will just let. Okay. This is 90 minus B, and this angle is A minus alpha because this angle also A minus alpha and this angle also A minus alpha. So it's cyclicity. Okay. And this angle is equal to this angle. So you get that angle equal to A minus alpha plus 90 minus B. That angle is equal to this whole angle, which is 90 minus C. You add both of them, you get it's equal to 2A. So angle FDE is equal to 180 minus 2A. Have you seen that such kind of thing before?
Oh, No,
Yes.
never seen it. Never seen it.
Okay, so D is equal to either feet
Wait,
or
is
either
this or the
midpoint.
midpoint?
Yeah, and midpoint is very nice condition because M go to infinity.
What? Oh,
Because
right.
like,
M goes to infinity, and then like it's like the
and
ratios are
I assume
D not
D is
equal to
a
D dash is still true, sadly.
wait, where you cook this thing there?
Wait, are we given that D and D dash are like finite points?
Can we assume that? I mean, if we
Like we
assume
can
it,
assume the problem is in Euclidean plane, right?
yeah, because like then like we essentially saying PQ goes to infinity, which still works. Like it's still cyclic and it's still perpendicular. Okay, perpendicular to the
Yeah, yeah, so we assume that D and D dash are like Euclidean points.
yeah.
Okay,
Like
that
if
is
it
so
goes to
cool.
if it go to infinity, then we essentially saying like this 90 and this thing is cyclic, which is recklessly true.
Oh, nice. So I suppose that it's just like happy now.
Happy, and we are done. Yeah.
Okay, so
Okay.
you can just explain that we'll go to P3.
Yeah, I will just explain. You guys will go to P3.
But I can't find P3. P3.
Wait, it should be
Oh,
there.
so
It
that's
will be there. Trust, magic happens.
Oh, it's to the right.
yeah, it is there.
Please, magic. Yeah, okay. I
Wait,
will
I will.
explain. Okay. First of all, we assume one. Okay, first of all, we draw the diagram, which is quite fascinating thing to do. So here's a beautiful diagram, and let's just put. Well, let's just put this there. Right now, don't assume D is feet or anything. We draw a whole concrete. Uh, okay, we get A, B, C, D, E, F, G, H, I, J, K. Okay, no, not H. Then we draw D dash, and notice that this condition is equivalent to saying like D dash, B, C are harmonic. Okay, and so if M is a midpoint, then we get like very nice harmonic conditions. So first of all, we draw this feet perpendicular. So this is P and this is Q. Okay, now we have this diagram, and now notice because like this thing is harmonic, we get the fact that if, from B we have Bm into Bd equal no, wait, Bm into Bc equal to Bd into Bd dash, and similarly like Cm into Cb equal to Cd into Cd dash. Okay. Now notice like if F is a theta perpendicular from C to AB, then we get like angle like okay, the notation is wrong. Okay, this is Q, this is P. Then we have angle PMC equal to angle PFC equal to 90. So that gives that cyclicity. And so now from that cyclicity, we use the fact like PF into BP equal to BM into DC, which is we by harmonically BD into BD dash, which this two facts give us like this is cyclic. I will draw a different color. This is cyclic for any point D. And like now you can use similar argument to say that like yes, Q, M, P, E are cyclic. And so by similar kind of like PowerPoint, you get this also cyclic, which is like, which basically it's like, okay, I will just write C into CQ, which is equal to CM into CB, which is equal to CD into CD dash because of the PowerPoint. And yes, that gives those are cyclic. Okay. Now, because they are cyclic, we also had like this condition that like if this angle is okay, wait, yeah. Now we had this. We use two of the fact. Suppose first like AD is perpendicular to BC. Then we know this is 90. Okay. Once we know this is 90, we know this angle is angle C because cyclic quadrature. We know that angle is angle C. So we also know that angle equal to this angle, which is angle C. So as we have P D dash C equal to angle BCA, we get PD dash parallel to AC. But now we also had like D dash D PC harmonic. Now you project, okay, this is equal to -1, and now you project this from P, and D dash will go to this infinity, so infinity along AC. uh, D will go to some point, which is like PD cap AC. V will go to A, and C will go to C, and this is also harmonic. That imply PD cap AC is midpoint, called midpoint N. So this point essentially is N. And now now that we have this midpoint and this is perpendicularity, this angle C implies this is also angle C, which imply this angle is also C. But we also have like ADM 90. So we get essentially angle PDA equal to 90 plus C. But remember, right, because this is 90, we also have this is 90 minus C. So we get A, P, Q, D cyclic. This was the first thing we wanted to do. Now we just copy paste the diagram for efficient method, efficiency. And now, okay, so now assume it's not 90. Most of the facts will be true except like these are angle C. Okay, you can still use cyclicity. Now we use the fact, okay, we call this alpha, like we name these angles alpha and this A minus alpha, and now we do angle chase. Very great thing to do. So now as we have AD, okay, this cyclicity, then we get like angle QAD, which is A minus alpha, equal to angle DPQ, okay, and which is also equal to angle D dash PM, because it's just reflection. And notice that because like yeah, and angle MPB is equal to 90 minus B. This angle is 90 minus B because this angle equal to this angle, which is B. So essentially we get that angle FPD dash is equal to A minus alpha plus 90 minus B, which is equal to angle FDB. And now we do similar angle chase. By similar angle chase, I mean like you consider this again in cyclocycle, this is alpha, then this is also alpha, and then because of reflection, this is also alpha. So now we have like angle D dash QA equal to alpha plus 90 minus C. You can see that because this is 90 minus C and this is alpha, and that implies that angle EDB is equal to alpha plus 90 minus C. This both because of both fact we get like angle FDE, which is 180 minus sum of those angles, which are A plus A. So we get like angle FDB E equal to 180 minus 2A. Now notice that E and F lie on 9-point circle. So if you like if you draw a 9-point circle here, obviously you have to mention the 9-point circle. Then notice like these intersection points are only like are subtended by this 9-point circle by EF is 180 minus 2A. So that's why D is either a feet of perpendicular, which is what we want, or it's the midpoint of BC. But notice if D is the midpoint of BC, then D dash will go to infinity. So M will go to also infinity and PQ will go to infinity. So we get like non-Euclidean point cycles, but those are like not Euclidean points, so we can't say the cyclicity. So that's vacuously false, and that's why D is a feet of perpendicular. We are
Just
done.
this will be like CDC here.
Uh, no, wait, what? This is true, right?
No, like EDC
Because
is dash QA.
EDC, yeah, EDC is like this angle is equal to this angle, and this
Yes.
angle is alpha plus 90 minus C, right?
Yes. You wrote EDB actually.
Oh, okay. Major angle. Okay. Yes, yeah, my bad.
Yeah, the rest
Okay,
is
I was Yeah. So we done with P2. Okay, what we still take 40 minutes. Okay, that's too much. And now we have very great
Okay.
problem by great person.
Yeah. Wait, I understood the problem. I'll just explain it, I think, because it's very hard to
Yeah,
understand.
that's way better.
Yeah. So like you are given this thing, you pick a now what you want to do is you want to create a sequence, like you want to just create a thing like B1 plus B1 plus minus B2 plus minus B3 dot 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 some stuff where each of the BIs is of this form. Like it's the minimum of some subset of the AIs.
We can choose the AIs.
Yeah, you can choose a subset. Yeah.
Okay,
But
we
the
can
subset is given of size
okay,
1,
we
right?
can choose each time. Also, but like we have to choose from beginning, right? Like we can't like just check the things and then choose something different, right?
You can choose something different. Basically, every term has to be of the form minimum of some subset of AIs. You assign signs like plus and minus, and you find one such expression such that for any assignment of values of a1, a2, an, the thing should evaluate to maximum of that a1, a2, an.
Yeah.
So like we kind of want to find like one expression. So any of the n values given, then you automatically get max of it,
Yes, yes, yes.
right?
So basically, that
You can say,
expression should
okay,
work for any ordering of the AIs.
okay, yeah,
Oh, any ordering of the AIs
any
as well.
order. Okay.
Oh, right.
Yeah,
Okay.
you
So if
can't order.
everything is constant, we just need one. Like, yeah, that
What
is
a
kind
great
of
idea.
trivial. Like, yeah, it's kind of
Wait,
dumb.
We
what I
don't
mean
know.
is you are not allowed to choose the values only of
Yeah.
AI. Like,
Yeah, yeah.
yeah, the
Yes, yes, I
expression
was
which you
looking
choose
at it.
should work for
Yes,
just all AIs.
yes.
Yeah.
Okay, so like for example, if n equals 2, then like we can choose a1. We can choose a1 and then we can choose plus a2 and then we can choose like minus min of
Yeah,
a1
A1,
comma
A2.
a2.
Exactly.
we need
Yes.
we need three terms for
Yeah,
it.
we need 3 terms.
And-
Oh wait, why not 2?
Yeah, because like if we use two terms, uh, we can't use one term, and we are going to use two terms. Then like we need information of both of them, which can't be possible because there are only three terms possible. Yeah, extra information. But this is process problem, then not algebra.
Okay,
Different.
so like we have by default like a maximum bound. Oh no, we don't. We don't. Sorry.
I mean, um, if we no, we can't. And if n is power of two, then we can cook some stuff, but that's still like okay,
Okay, for
yeah.
any
If
three,
n is
what do we
power
do?
of two, n equal to three.
Yeah.
Yeah.
Oh, A1. Oh, this is like probably
Yes,
some
take.
principle of exclusion inclusion thing.
Yeah, that is what I was thinking as well.
Yeah,
We should just take these three for starter,
Yeah.
then subtract the min of A1, A2. That will subtract one of those. Oh, what if we just
okay.
take the exact like oh, what if we just do like min of A1, A2,
Wait, all
min
AIs are random. Okay.
yeah, yeah.
I mean, like, what if they are equal? Then he just choose random. Okay, sure.
A1, A3
Yeah,
Yes,
plus
but okay. So if we assume this thing, then
A1,
essentially we're
A2,
getting
A3.
A2, A3, A3,
Yeah.
and A3. So we get the expression
so we get the maximum
A.
basically.
We just get A1.
Oh yes, you get.
Yeah,
Oh
so
nice.
this
Okay,
works.
but
So
how
we
much
get
terms this
7
get?
term.
Okay, what will be the
7.
general number of terms? So it will be
I mean,
like
like,
It looks like
I
2
think
to
so.
the
You
n
can.
minus 1. It would be 2 to
yeah.
the n minus
I mean, you can do it. Like there should be lower. I think that should not be wrong.
1. No,
Or
I
should be
don't
too
think
much.
you should get a bound lower than this. It's like the principle of inclusion
Uh,
exclusion
this
for a reason.
this works like this
Yeah, this works.
inclusion
Yes.
exclusion just work for n, right?
Yeah.
Inclusion exclusion
Yeah.
will work for n. Yes. Okay, we still have to prove how it will work, though. Is it like obvious that it will work?
We just assume it's obvious.
Assume it's obvious. Easy.
I mean, can we like phrase it in Venn diagram and somehow just like cook the stuff?
Okay, like no Venn diagram for n things will be good. Like,
Then you essentially going to say that
wait,
if
so
we choose this,
wait, so okay, we need to show that this always achieves it, and then we'll have to show that you can't achieve it in less than these many terms. So we'll
no, but
probably just construct the
this can
sequence with
be just true because like, right, you choose like this thing, okay, and suppose this is AI and this is AN. Now just consider these terms, okay, and it's just exclusion of this, and like the number of times you taking plus of this, number of times you taking minus of this in like only this section, and if you're going to use any of these number, the minimum going to be like somewhere here. So it's like induction on this thing, and that gives us like this will go give A1 always to get the idea.
no, that does not show minimality, right? Okay, sure, you can assume that the minimum is that. Then what do you do?
So no,
And
so
you can
like
like
suppose for like
regroup it into
A1,
this.
like suppose like for A1 to AN, we by like exclusion inclusion, you get the A1 as a minimum, and now you're adding AN plus one, which
Yeah,
is basically like adding AN plus one, then subtracting like assuming like it's minimum. Uh, so you're going to
you will have to
subtract
show
it
that
like
you require
sometimes.
2 to the n more terms. Please.
You can't just assume it's minimum though, right?
Yeah.
No, so but I'm saying like my idea was like consider some AI, and if you're going to use like only this subset of numbers, then like by induction hypothesis you can say like this term will vanish in everything, like
Okay, you're
all the
saying like we can get
terms,
the maximum of
and like
some items.
mm, something like that. But I think yeah, I kind of get why PI will work. How you show induction. Okay. Okay. See, first of all, assume like this is true for first n numbers, and like so like for any n numbers, this is work like P works, and now you take n plus one numbers. Then like for this n plus one number, only consider first n numbers, and like if you apply like all these sets
Yeah,
for
you will
n
just
numbers,
get
we get
the
A1.
maximum out
Okay.
of that. Sure. Yeah.
Now
You get the number, you
other
get the
part of
maximum
terms,
out of it.
yeah. I mean like so other part of terms like involving an plus one, but like an plus one will involve like ones in like what two, like it's like what you call one choose n choose zero, n choose two, something like this, and
Yeah,
like
yeah, 2 to the
this
n
time it will
terms. It's
come
a 2 to the
positive,
n terms.
yeah, and this time it will come negative, so it will just cancel out. So there won't be any an plus one term. So we get a1 on this. So PIE works.
Wait, what?
I mean this
No, that is false. Why are you
like
assuming an order? Why are you assuming an order?
no, I'm not assuming order. Like you
And we
order
already
some
know
way.
PI
Like
works though.
you
Like we
order
already know
all
PI
AI
works.
in some. Yeah, PIE works. Yeah.
But we already knew
Okay.
that.
My bad.
Wait, sorry, I don't get what has happened.
Mm,
Who has
Never
proved
mind.
the claim that we
Just
have
forget about
proved
it.
earlier?
Yeah. I'm just doing the same fact we're doing earlier.
Okay, wait, this.
What's
Okay,
what
we
can
should
be the
see if
best
we
way
can
to
like
enter?
do this thing. What do you call it? AMB. This.
Okay, we do less than that.
Uh, you can say it this way. Okay, we can prove that it works. Like we can prove that the pi works by induction.
Yeah, that's what I did. Pi works for induction, but now we need something less.
Yeah, pi works by induction. Now we need something else. Wait, how do we get this? I'm pretty sure we can't do better than pi. Like,
I think we need to like deal with the information, like how much information we're getting for minimality. This seems like so much true because of
okay.
this. And this makes sense why this question is like wild flavor,
Yeah.
definitely. For
Wait,
obvious
the
reasons.
amount. Okay, what is the amount of like the information that a min gives you? Okay, it can
Wait,
be a lot
actually,
depending on what.
wait, can you actually use entropy here?
I don't know, but the point is like it can be a lot depending on how many things you have inside it, right? I mean, if it's n, then
Maybe.
you will get n bits of information. Not okay, you won't get n bits of information. You will just get some weird thing that one is greater than the like less than the others. Okay, I don't know how many bits that is.
We essentially need ordering only, but we need
Now, can we do this kind of thing? Like, assume that there is some algorithm with a smaller number of functions. Like, we know that
Okay,
this algorithm, the PI algorithm, is covering every single possible term, right? Like every single possible minimum function.
okay.
So we can just say that if there are less terms, then by PHP, like one of the terms is not used. Uh,
wait, what?
It,
I mean, like, if you look at the A1 into A3 term, like it's using every possible function of the minimums. Like, do you see what I'm saying?
Oh yes, so any possible
Like there are two to
function
the
with
n
less
minus
than
1.
this will be a subset of pi.
Yeah, so what we can do is like we can swap two terms and say that this will give us something different. But it should work even if the terms are swapped.
Right, yeah, that might work. Yes. Okay, so we just want to show that any subset of pi which is not pi, I can something that is bad. Okay, that should be good.
can you prove a 3? My pi is the best.
Oh yeah, that should be a good idea. We should prove
Okay, so
pi
first
for
we get
three.
one thing, like what we can say is that every term has to be like, okay, see, we can say that the maximum term has to be added like at least once, right, to get the maximum.
Yes,
Yes. So we
So if,
have to add all of them because
yeah,
we don't.
exactly. Like this
Yes,
is first.
good point.
And now we need to subtract the second largest term, like at least once.
yeah, we need to do that. Yes,
We
that is true.
can't get the second largest term unless we like take every NC2. I think, how do we find the second largest term?
Oh yeah,
One.
okay. This is just like we want to find the second largest using
Yeah,
min.
like see, if we need to take a minimum of like AI comma AG, right? Like because if you take three terms, then like the second largest term
Yes,
will never be the minimum. So what we
yes.
can say
Okay,
is that, sorry,
wait.
So
So
we need.
you to get okay. Wait, you're not given information, right?
yeah,
Wait,
and
that
now
kind of works. Like for second largest one, we need to take almost like all of them.
yeah,
Or
exactly. We
can
have
we
to take all of them, and I
We
will
will have to take stuff more than all of them.
no, we can't like. What do you mean more than all of them?
I mean, like we need at
Oh,
least all
nothing.
of it.
Like, okay, you'll have to subtract stuff.
Yeah, we
But
need to subtract
yeah,
all of them because assume like so the only way we'll get second largest as a minimum function is that if you get a1 comma a2. Like this is the only way
second
you'll get.
largest and the largest. Yeah.
Yeah. And the point is that
No,
assume
it can also be the second largest and the largest.
that's what I said.
Wait. It can also be the second, like minimum of second largest and largest. That also gives you.
Yeah, that is the only thing that works. Like nothing else can work,
Yes.
right?
Yes.
So the
Yes.
point is that assume you have not taken this function, then you are just like cooked.
That is
I mean, the
So
point is
we
that you have to take every NC2 possible combinations because if you don't take one of them, then you can swap the terms such that you know the that combination that you haven't considered is the one.
oh wait
Oh,
so
right. And
so like
similarly, to subtract the second, you need NC3 because you could
Yeah,
so
construct
so
wait,
I
anything that
that
doesn't.
okay, you're saying like if it does not take one of them, then you can swap A1 to A2 and then it still works. So
yeah.
you not don't. Oh wait, yeah, that makes sense. That's may not.
So aren't we just
Oh,
done?
yeah. And like you can't get an A2 from a thing that has more than like more than greater equal three arguments. If it has greater equal three arguments, you can't get a like the second largest at all.
Exactly. You
That's
can
just
say
not
that
possible.
you can say it's symmetric because
Oh,
like you can say it's symmetric because like swaps work. Like if you swap it, then it has to work as well. So the whole thing has to be symmetric.
yeah, exactly.
So
Wait, so
are we
wait,
done?
that is true.
Then we should be done. Okay, well,
Yeah,
how
I
you
think.
how you make this for k terms? Like okay, three terms. How you do that?
Wait.
Just
But you're subtracting this, but in this process, you are subtracting a lot of collateral as well.
Yeah, that's the point.
Oh
Like
no, okay.
the
That
point is
makes
that you
sense. Okay, sure.
have them. So like you have to then again add each of those terms those many times and so on.
Oh, okay, yeah. So in this thing, when we are taking everything, the number of times the second guy will be subtracted
Is the number
is
of times the third guy will
precisely
be subtracted.
twice.
wait. Why second guy separated twice? Like,
Okay,
we
hang
just
on.
have
Let me just do it for
Because
like
like
everyone's
no, third guy, not the second guy,
yeah third guy
third guy will be subtracted twice, and then you need
and
to
then
add it back, and then that is
and
just the
because like if we not take one of them, then you can again like choose like something and you can turn over the stuff.
Okay, so like let's just
yeah, exactly.
prove for n
Let's
equals
just
4.
like formalize this and
Yeah.
n
Then
equals what?
we mainly formalize like why not taking
Okay,
one term will like
So n equals
yeah
4, you have to add a1,
okay,
a2, a3, a4.
yeah. So
And
this
now you
gives you
have
like
to
four terms.
every possible pair.
Then you need to subtract like 4C2 terms. In
Yes.
this process, the second largest gets subtracted once, the third largest gets subtracted twice, fourth gets subtracted thrice. So now you need to add this term back in. For that, you need to find it, which takes 4C3 moves. And in this process, you are adding this guy once and this guy twice. No, this guy.
no wait.
Wait,
In
let
this
me.
thing we added everything plus one plus one plus one. So second largest gets subtracted. We want third largest to be added.
Wait,
So
let us 1, 1, 1, 1. Then it becomes, after this operation, it becomes 1,
zero.
0, -1 and -2. Right?
Yeah.
Yes. And then the
And after
4C3 operations,
1, 0,
this guy goes.
this guy increases
Zero.
like every term increases exactly once. Sorry, not every time.
Yes. No. See, if you have the.
Hang on, no. How many subsets is this the minimum in? It will be exactly like,
Wait. Yeah, and okay. Yeah, that is correct. Everything will be subtracted, added once. Wait, no. Surely not, right? Okay, you have A1, A2, A3,
okay, no, we need to look at
A2,
like,
A3,
you have A1 is greater than equal to A2 is greater than equal to and so on is AN. So all we
Yeah.
want to do is that in like when you're taking K terms, in how many of them is
Yes.
AI the minimum? Like, yeah.
Yeah. Yes. That
So
makes sense. That makes
basically it's
sense.
like,
Oh, isn't that just like KI choose?
yeah,
Wait, you just take the numbers which are all larger than it and then
exactly.
Yeah.
just like add
That
it.
was I was saying. Yeah.
Wait, no. Will that always give you a 1?
No, it
That
won't
is
give
not
you.
that won't
It'll give you one.
necessarily give you a 1, right?
It'll give you 1 if k minus 1 equals I, right? Something like that, I think. Or k plus 1 equals I.
Wait, okay. Wait, no, let's
No, no, wait, wait.
see. Suppose that you're looking at the ith term. It is the minimum.
Hang on,
Uh,
let's.
oh, it
If
is
you.
minimum like some 2 to the I minus 1 times actually, right?
Yeah.
Yeah.
Yes.
Yeah, okay. It is the minimum 2 to the I minus 1 times, excluding the first case. Oh, this is just a pi on this. This is just a pi on this.
Yeah, yeah.
Right, as it's just the pi on this. Wait, why should it give you 0 if it's the pi?
Okay, see. There are AI, right? You have AI. So the only way this can work is if there are like uh, all the terms are in this subset, like A1, A2, and so on till AI minus 1. And you're taking the
Yes,
k,
that is correct.
like the number of times AI will come is equal to
2 to the I minus 1.
choose I minus 1.
Wait, no, it will just be 2. Okay, you're taking k things at once. Okay.
Yeah, so k minus 1 choose I minus 1, right?
Yes.
So now all we need to do is we need to prove that sigma of uh, hang on, no, yeah, 1 to I
Wait, what?
Yeah.
k minus 1 I minus 1 is
Wait,
equal
I
to
guess you guys did
Minus
it wrong.
1. No,
It
you
should,
also have like a minus 1 power here. A minus 1
it
power.
should right. It
No,
should be
it should
this.
be the other way around.
yeah, my bad.
It will be the other way around. It will
No,
be the
like
other
you're
way around.
choosing k terms. You're choosing
Oh,
k
right.
terms,
I'm
right?
choosing
Out of
k
like this.
numbers
You're
from
choosing k
this.
from
Right,
this.
right.
Yeah.
Yes.
Yeah,
Oh,
that's
yeah.
right.
So
And then that is just an
everything.
obvious result, right? That is just
Yeah, that is
obvious.
obvious.
Because you just divide it in half, half, and okay. Wait, but why does the same argument not work for an and give us that that is also 0? Like, what is the term we are missing?
No, the
What?
point is that hang on. That's wait, there's
Oh,
also
because the
0.
set we are choosing from is 0. The set we are
Yeah,
choosing from is 0. That is why.
exactly.
Yeah.
Okay, yeah. So we are done. That works. Okay, wait. Did this take us the least time by
Yeah, yeah.
comparison?
So the day one
Like,
was like day one was put in the reverse order, basically.
It took I think like 20
They were
minutes.
scamming.
yeah.
Okay, wait, Atharo, do you want to explain this? Atharo.
Yeah, sure.
Yeah,
Uh,
that is an explanation.
so what we
We'll
have
look
done.
at these.
So first we found that principle of inclusion and exclusion works because you're adding every term and then you are subtracting them. Basically, this works on the principle that if you take every term and then subtract every pair of 2 and then add every pair of 3, you get the largest term. Wait, have we proved that this?
What?
It's basically like this, right? Like if we're going to like if AI come to like as a function, then it has to be like half of the time plus and half of the time minus because like AI choose
Yeah,
like if AI comes to be answer, then it has to be like you choosing set from A1 to AI minus 1, and which is basically like you're going to choose k minus 1 terms from I minus 1, and this k can hover on like what k equal to 1 to I minus 1.
I mean, this
And
one
because
is
we
the
are
case.
doing
No, K can start from 0. K starts from 0. K starts from.
no,
Oh,
so
sorry.
that equivalent is like
Subtracting 1. Sorry.
we are going to choose AI, yeah. And now by PI, like we know like this like by PI we going to choose like this plus and minus. And so summation of this with like what is whatever is that k or something is 0. So except like I is not equal to 1, and that's why it works, right?
yeah.
Yeah, the same logic. And now like why like we need all of these terms?
Yeah, so the reason
What
we
like
need
formula?
this is because to get the maximum term, it needs to be a function of minimum of some terms, but the only way the maximum can be a minimum function is if it's the only element. And since we don't know which
Yes.
element is the maximum, we have to take all of them at least once. Now, after we've taken all of them, notice that the second largest term has come in this expression, but we want to remove that. So we need to subtract the second largest term. But now if we take like an expression with only one term or a minimum expression with one term, then by symmetry, we'll get that the largest term will also be subtracted. So we need to take at least two terms. And if we take like three terms or more, then the second largest can never be a minimum function because there are at least three elements. So the only way the second largest can be the output of a minimum function is if there are two elements, which are like A1 and A2. And since we don't know which is the largest and second largest, we need to take every possible and choose two terms. And now after this, again, due to overcounting, the third largest term is added exactly once. And we need to repeat this argument. Oh, is that clear? Okay, wait, there is lag in the chat, I think.
Yeah.
Wait, I
Maybe
think
this
it's clear. I don't think
yeah,
anyone
it
has
should
seen.
the main point mean like if we like miss any term, then we can like change some two AIs and like, things
Yeah.
works out.
P4 just
Right.
looks like binary search. How
Right.
is it binary search?
Like from top to bottom for D2, like P6 seems to be very easy.
We move on, right?
Nahi,
Yeah,
bhai,
Well,
let's just do P4 first. Let's just like get the hard problems out of the way. Yeah.
Okay.
no, no,
P4 is
yeah.
probably hard.
I
Okay,
think like yeah, P4 is hardest, like P6 is P4,
P6.
yeah, P4 is hard, I guess. This is easy. Okay.
It seems
interesting.
easy.
Real like.
Vikram Beta.
Playing a game and let's see some players. Okay, sure. Why this is again OI type? What is Archit and Siddharth doing?
Yeah, Ajit and Siddharth are both like looking just OI problems. Hmm.
Wait, what is this like? Oh, is this? Okay, obviously.
I mean, 13 is that number.
Okay, yeah. So we need some binary division.
It's probably just binary search somehow.
Yeah.
But we'll have to figure it how.
Okay, so surely like you have to ask the minimum and maximum, right? Like that's what it should be.
It's
Yeah, like you can wait, what?
Okay, should we do this for like five? Yeah, like instead of 2025, use five.
Okay. Yeah, let's do that. Uh okay, I
What is
ask you the third one. Okay, like just
log
okay,
two?
I'll play Vikram, you play Vedant.
Hang on, what is log two of this? Four questions, right?
Uh four questions, yes.
Yeah, okay.
Okay, I'll play Vikram, you play Vedant, or like I'll play Vedant, you play.
Yeah, yeah. Go ahead.
What do you want to play as?
I will play Vikram.
What do you want to play as?
Vikram.
Okay,
So
then let
first I will
me
ask you
find a
A1
notebook to
and
write
A5.
everything on.
It's okay.
Okay, first of all, we can just shift the
Okay,
sequence.
yeah.
We can shift the sequence appropriately to assume that A1 is equal to 1.
What? Why?
Like by just like subtracting constant from every term. Like it doesn't matter.
Okay, sure. Right, you even if you have equality.
So yeah, you assume A1 is 1, so you ask for A1 and then you like shift it appropriately. And now you ask for A5. So if A5 is not equal to 5, then we know that such indices exist.
That is true. Yes. Okay, So I will pay to you right. So then do we just ask the keep doing? Okay, then we ask the middle guy to check if the indices exist in the middle guy.
Yeah, I think this just works out, right?
Maybe. Probably.
Okay, so you have, I think we should shift to 0. That will be more convenient. So like,
Yeah, it
uh,
could be.
if we have a5 equals like 4 or -4, then we just know that no such indices exist.
Yes.
Otherwise, we know that a5 is in this range.
Yes.
And we can like assume it's not 0 as well, because then also it'll be done.
Yes. Now ask you like
Now,
A3 and
three.
check if it's in the range like -2, -1.
And we just check whichever gap is smaller.
Yes.
But doesn't that just work?
Yeah, I think it should, but I feel it should not. Like, no. I mean, it's a matter of like, this is
Okay, no, it doesn't have to work. For example, a sequence could, I don't know, go something like 0, 1, 2, 1, 1, kind of, I guess. Like, I don't think just asking the middle term will work every time.
okay, sure. See, so you get 0, then you get this, so you know that indices exist. Now you look at the this guy in the middle. So you get that it is 2, but now you know that the last guy is 1. So you know that the middle guy has to be 1. So you're
Oh, could you repeat that
right.
argument?
You're that is what?
Or could you repeat the whole argument?
Yes, yes, yes. See, so you know that you have a 0 and a 1,
Yeah,
right? Then you ask for A3, you get a 2, and then you know that this is a 2 and the last thing is a 5, is a 1 as well.
yeah.
So the center thing also has to be 1. Okay, I think we should also use this like when I'm asking the middle guy and I know the last guy, like there is only so much that could have varied. Like I get that the numbers in that range are also like bounded by. Okay, I think we need to use that as
Wait, I have one question. What if like our sequence is something like this? Like 1 minus epsilon, 1 plus epsilon,
What do
1
you mean
minus
epsilon?
epsilon. Some small
well.
number. But like
It's
if
No,
you
an
like,
never
isn't that
integer.
they are all integers,
like
right?
but
Oh,
wait, what?
integer.
Oh my god.
Yeah,
Integers.
otherwise the problem would just be impossible. Like, come on.
Yeah,
Yeah, I was like so confused what is happening. Okay,
integer sequence
fine.
is like force the differences
Ah, okay,
one
okay.
as
Now
well.
now
So
it's
it
now it
should
should be
work.
three. Wait, so okay, consecutive. Okay, now this should be. Okay.
Yeah.
So can you hear some background noise? Oh, no,
No, not from your
no.
end.
Okay,
Okay, wait, Mandar,
so,
so
okay.
your argument is like what is your argument exactly? Like, what is your strategy?
No, it doesn't work for a general thing. It does not work for it.
Yeah, I think what strategy
But
I
for
would,
this case, it's pretty. This case, it's this, no, this case it just works. Like asking the middle guy in this case just gives you the
yeah, but like what I'm saying is I think we can get a better strategy. Like, assume like, okay, first what we'll do is we'll consider a1 equals 0 and we'll like subtract everything appropriately. And then what we'll do
okay.
is we'll ask for a5, and if a5 is like negative, then we like just multiply every term by -1, or if it's positive, then we like leave it as it is.
Okay.
And now the point is that we if a5 is like equal to k, or like an is equal to k, then we will
Yeah.
ask the index like an minus k.
Oh.
I think this should work, right?
Okay. So if it is equal to n minus k, or like if it is equal to 0, then you know that it is strictly equal to 0.
S-
Yeah.
Right?
Or it could be 2k In that
Yeah,
case,
like
it's strictly
it cannot be
decreasing.
zero. It
So
just
you have
cannot be
all
zero.
the number of successes. It can be zero, right?
No, if it is zero, then like we just like win
I mean,
by
in that case, okay, if it is zero, like you are somehow just happy.
yeah. So like it has to be like
If it is
one
zero,
or
then yeah. Wait, if it isn't, it can be zero, right? And you can have a like up down structure, so you
yeah, no,
can't
no.
directly know it.
If it is zero, then like we can just take that A1 and that like that's already
Right,
valid.
sure. Okay. Yeah,
So
yeah,
like
yeah.
if that's zero, then we win, and if it's not zero, then like again we I think can induct, I guess, in some.
Yeah, 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 yeah. Wait, if it isn't zero, and if it is n minus k is like k total moves, right? Okay, no, this is okay. Ask n minus k minus one actually, like instead of this,
N minus k minus one. Oh, why?
because like I just yeah, because I just want like the thing you ask, the number of terms in front of that should be k. That is all I want. Right?
Yeah,
Like the number
yeah,
of
that's what
like
I'm
c.
saying. Okay, I see what you mean.
Yeah.
Yeah.
Yes.
Like basically the point is that if this term is zero, then everything has to be like plus one after. Right? That's what you're
Yes.
saying.
Yes.
Yeah, yeah.
Yeah, that is what I was saying. Like, if it is 2k, then we know that it is everything is like less than this. It just keeps going minus one, minus one, minus one. So that way we can probably just bound it nicely. Wait, we know bounds on this as well, right? If this is k, we know that a n minus k minus 1 is like from 0 to 2k. We know that as well. Wait, then maybe we
Wait.
multiply stuff. Wow.
I'm pretty sure this algorithm works like it should be trivial to uh,
Wait, I'll be just back.
Wait, so what's your logic like whole point again?
sorry.
Wait, what was your algorithm again?
Oh, the algorithm is that hang on. The Miro is refreshing for some reason. Okay, wait. Yeah, okay. So the algorithm is that you ask A1 and you then set it to be zero, like by subtracting constant for everything. And then you ask A5 and then you like make it so that A5 is positive and like A1 is zero.
Yeah.
So now the point is that if if A5 equals K, then you will ask the Okay, for example, if A5 is 4, let's say, not 4, 3, then you ask the term such that you ask A5 minus 3, so like A2. So if this is 0, you're just done. And if it is like 1, then you again replace this with 0 and this with 2. And now
Okay.
you ask the term such that, hang on, no, I don't think this algorithm works.
Yeah, we can still do the binary search, I think.
Oh yeah, we can still do binary search. Like one of these groups will be smaller than n by 2, so we'll just take that group instead.
Yeah, exactly.
Yeah. Okay, I think
And even better, like, see, A3 cannot be like, okay, for A3 we have that it is like 2 minus 2, but like 1 and minus 1 are not achievable value. Wait, is the absolute difference equal to 1 or is it at most 1? Oh, it is at most 1. Okay, that is okay.
no, that is
Okay,
still
in that case, if A3 or this is like either is 1, then we are just done. Like, if A3 is plus minus 1, then we are just done.
hang on.
Because A2 then will have to be 0. See,
What I'm saying is
my
that
point is, yeah, go on.
okay, so like if you have A5 equals some number, you take the number such that
Yeah.
that number would be 0 if the difference of everything was constant, like it was 1.
Okay. Yeah.
Okay. So the
Now we know that
yeah.
this number that you have taken, it has to be positive. Like if it was negative, then you're adding 2 in some place, which is like not allowed.
Yeah.
So this number has to be positive, and since A1 is 0, and this is positive, and A5 is like greater than this, you
You
can
get a
like
smaller subset to work on.
yeah. In fact, like the small subset of
Right.
like less than n by 2.
Yeah. Yes. But like,
But
what if the jump is like too small? What if the like or maybe too large? See,
No, like the point is
the
that
issue I have is we have. Sorry, go on.
oh, sorry, what is the issue you have?
no, wait. I kind of get your idea, but issue might have is like, okay, you get an equal to n minus 1.
Yeah.
So this is like 2, 3, and like somewhere here it's plus like equal. We have to
Yeah.
now like find some like we can confirm this.
Oh no, then we just do induction. Then we do induction.
Hang on,
No,
if this is 0 and this is n minus 1, then we already know that there is no two terms of equal indices.
oh no, wait.
Yeah.
I mean n minus 2.
Yeah, okay.
That's something. Yeah.
So now we take
If we take this subset, then it will be like kind of same, but like one smaller side. We will need like half of it. Like, but these two terms can come anywhere here, right now, right? But we kind of get a lot of information. That's true.
That is true, yes.
okay, wait, no. What we can do is we can take now we can take n by 2, right? an by 2. Because like we know that term is going to be
Yeah.
positive.
Oh wait, yeah. Like we now know they're almost consecutive with just one change. So we just do binary search. No?
Yeah. Or we need
Wait,
to
that
like
works.
rest in some way.
So wait, yeah, this is true. Like either they it will be plus. Wait, what if like this comes way low? Oh, so you mean like oh, so first one term you just remove to like get to here, and if this comes out to be nice, then like we just do binary search here. If not, then we do binary search here, or like
Yeah.
n-
Okay,
and
let's
wait,
just formalize this.
yeah, that is nice. Uh,
Okay, so you have A1 to AN,
yeah,
and now
put a1 equal to 0
A1
if
equals
we are
0 and AN equals like K. So now if K is greater than n by 2, then AN by 2 has to be positive. AN by 2, like AN by 2 has to be positive.
yes.
Yeah, so we just take then AN by 2 and we have reduced it to half the size. And we have used two questions, like one question basically.
Yeah,
Wait,
and then we are just done.
Yeah.
wait, can you repeat again? Wait. Uh,
Okay, so first we use like the first question, like you have log 2
yeah, this is true.
n
Yeah.
plus
Yeah,
1,
I
right?
get. Yeah.
So you use one question for finding out a1, and now you use the other question for finding out an.
Yeah.
Now, if k is greater than n by 2, then you will ask a n by 2.
Okay. And why it's true? Like, okay, you ask k n by two. Okay, and
This
then
has to be positive because if it's like less
yeah,
than this, there would be a jump of 2 somewhere.
yes, like this is positive. Yeah.
So this has to be positive, and since okay, I think we can say that it's also like in this range, like it's in the range 0 comma k plus n by 2.
K minus n by 2, right?
No,
Oh no,
like
sorry. Okay.
Plus it
Yeah,
could
yeah,
be like increasing.
yes.
But the point is that if it is k plus n by 2, then we just
oh this okay. He meant like this can be this is this like,
Yeah, K minus n by 2 to K.
oh yeah, k minus
because
n by 2.
like yeah. Uh,
Okay, wait, but I think we can prove that it is like
but we miss the fact like you can use minus one too, right? Like somewhere.
no, I think we can prove that this is like at most k or something. Oh wait, of course, this is at most n by 2. Like this is at most n by 2. So this is like k
Oh
minus 2
right, because
comma
like
n by
AI
2.
minus AJ. Sorry.
Yeah, yeah. That's
Wait,
the
it's
thing.
just like we just use that AI minus AJ is at most I minus J, right?
Yeah, exactly. So we know
Yeah.
that an by 2 is positive and it is between 0 and k.
Yeah.
Yeah.
So now we just repeat the same argument. Like we take an by 2 equals like
0.
whichever is the smaller
Like you
part we take.
subtracted by everything.
Yeah.
Wait. But
And
which
then you
set you
just
going to take like out of these two?
Like whichever has a smaller difference. Like this is the value x is like 0 less than x less than k, right? So
Yeah.
if x is greater than k minus x, then we'll take the this bound.
like
But
if it
if
is less than K by 2, then we take the first half. If it is greater than K
I don't think it should be
by
like
And
2, then we take the
mathematical.
second half.
Like I
and
don't
why?
think,
What?
Okay.
but yeah, we'll take that bound anyway. And now the point is that you've reduced the problem to n by 2, and you've
Like
used
are
only one extra question.
Right. So if this is true, then we're going to take like this an minus a to an, and why it's sure like there's zero exist in between here
Sorry?
because like why it's sure that we know there is like constant between these terms.
We don't, but like, uh,
You can't use both of them, right? We have to use one of them each.
yeah, but like one of them will definitely have a constant, right? So just choose that
Yeah.
one as a constant. Like the point is that if you take the smaller one, that will, you know that there is a constant because otherwise it will just be like equal. I mean, like for the 2025 case,
Yeah.
uh, you have like, let's say this is 0 and this is 2024 is like, you just know then if 20, assume this 2022, right? And the
Okay.
middle is 1011. What this would be
Wait,
101
sorry, I have
maybe.
a question. Isn't this taking you like two more than the usual binary search? So like we should
No, but
have
the
like
point is
instead of
that
okay, wait, did I make a calculation error?
no, there is no calculation
Wait,
error.
wait,
The
I
point is that the first two binary questions you're using for finding the like end limits. But now every time you ask a new question, you already have the ends, right? The endpoints.
Oh right. Wait, so should we not just be able to do this in like log of 2025 ceiling? Why do we have the plus one?
The plus one is for getting like the original. The first time you do it, you have to take two endpoints, but after that you have to take only one. So there is like an extra question in the beginning.
Wait, in fact, it is not even this. Wait, it's like log base 2 of this plus 2. You have two extra questions. Where
Yeah, it's
are we
this.
taking the two extra questions?
No, no, it is like one
It's
only.
not plus 1, it's plus 2. No, no, for 2025 it is plus like 2.
Oh
Yeah,
yeah, for 25 it is plus two. Yeah.
it's like
Yes, so
10.
like we are
And
taking two extra questions.
yeah, the first question, like two questions go into like A1, AN, and then you use binary search, right?
Yeah.
The binary search start from middle. So like now you start middle thing.
Yeah.
But like in the binary search, you might have had seen the endpoints, right?
What do you mean?
Like you might have to use some of the things in the endpoint. Wait, does binary search take ceiling or ceiling plus one? I think it takes ceiling plus one, right?
No, I think it takes ceiling only, right?
Oh wait,
Like,
wait, wait.
Okay, so we are using two extra questions. Where are we using that?
and the two questions are for the first thing, right?
Wait, but but in the binary search itself, I might have had to check these
Hang on, for like
endpoints.
one,
So were
for
they
like
not in?
for n equals 5, we have to like ask A1, then we have to ask A5, then A3 and A4, right? So that's taking 4 questions, which is like,
Oh, right. Okay, sure. I understand. Okay, yeah. So I
I
think
think
we are
that
just.
plus one or plus two thing comes because like 2025 is like not the power of two, I think.
No, it is accurate because even in the binary search, normal binary search would take us three, and in that three we would have asked A2, A3, A4.
Yeah.
We would never have touched A1, A1, A5. That is why the plus two.
Yeah.
Yeah, so that is why it works.
Okay, now we need to like just prove that this algorithm does work. So for k greater than n by 2, we're done, right?
Yes.
And now assume k is less than n by 2.
Wait, why? Yeah.
Sorry?
Wait, I don't get like we are not considering you can choose minus one to right? Like
No, we have considered that. Like
oh
we are
wait.
done for k greater than n by 2.
Okay, yeah. Oh, my bad, my bad.
Like the point is that x would be positive, like definitely.
Okay.
And if k is less than n by 2, less than equal to n by 2, then we just ask like a n minus k minus 1. Because this can be at most, like this also has to be positive.
Yeah.
And the
Oh,
point
but
is
like
that,
then we can just instead of doing this, we can just start with the middle one only. Like we have enough things to waste, right?
no, I think that does work. But like the problem with the middle one is then it could be negative
Uh,
for like k less than n by 2.
no, but then you like rescale it. Then you rescale it by okay, you have this middle one. Suppose that it is negative and it is like
Okay, yeah,
some
fair enough. You
minus
can just
t.
increase it to
So
0.
you
Yeah.
like add t to everything.
Yeah, so you can
Yes,
just take the middle one no matter.
that argument.
So you just do
Yeah,
binary search
exactly. Like
one.
it's just normal binary search. There is
Yeah.
no issue. You just do binary search with the fact that like AI minus AJ is upper bounded by averages.
Yeah.
Okay, that just works.
Okay, so we're done.
It's nice. Nice
Okay,
thing.
now it's NT.
Okay. Um
Wait,
wait still. Wait still.
let's NT. Finally we have NT.
Athara, welcome.
Yes.
I'm just so happy to see a NT for some reason. I don't
Okay,
know
so
why. I'm
the,
just
yeah.
very happy to see an NT.
Okay,
P
solution
for
A.
solution.
I
Yeah.
think
P for
Uh,
solution.
yes, P for solution. So first we claim that binary search works. And this is true because if you have A1 and A5, you can ask A1 and A5 and then like you scale it appropriate so that A1 is 0 and A5 is like positive. And you can do this because like you subtract a constant from every term and then you can multiply by minus 1. And now you take the middle term, A3. Like, okay, I should take like an by 2 or n plus 1 by 2, whatever. So you take the middle term, and now there are two possible cases. The first case is that if an is equal to k, then the cases are k is greater than n by 2 and k is less than equal to n by 2. So if k is greater than n by 2, then we have a bound on the middle term. So the middle term has to be, it's lower bounded by k minus n by 2 and it's upper bounded by n, sorry, I think this, and it's upper bounded by this. But the point is that uh, this middle term is going to be in between 0 and 0 is less than equal to the lower bound of this, and the upper bound is less than k. So essentially, we've reduced this problem to a problem of size n by 2, but with the same conditions. And we can always choose a terms is that uh, assume that two indices do have the same value, then one of these is going to be like less than k itself. Like we cannot have that a1 equals 0 and a n plus 1 by 2 equals n minus 1 by 2 and a n equals n minus 1. We cannot have this because then just none of the indices would be equal. So this has to be like a n has to be less than n minus 1 and a n plus 1 by 2 has to be in between these. But by PHP, there are like more terms than the number of integers. So one of the terms will be repeated. So at least one of these bounds from a1 to n plus 1 by 2 and an plus 1 by 2 to an will have some repeated indice, and we can just then work in that region. And if k is less than equal to n by 2, then we can just take the middle term again, and again this is like bounded in two directions. I think it's k minus n by 2 is the minimum, and the maximum is k plus n by 2. But the point is that since k is less than n by 2, I think this bound is less than n again. And so again, we've just reduced the problem to a problem of region n by 2, and with the we just used one question. So I think we're done.
Yeah.
Okay.
Wait, Atharva, like what we said is like k is greater than n by 2, and then we're going to work with this area, right? That's what we say.
Like
Or no?
either this or this, yeah.
But which one we choose? Like
We choose the
choose.
one where where we know that an index is repeated, and we can choose this because like you have like a1, a1013, and a2025 for the 2025 case. So we know that this is 1 and this is k, and this will be like
Yeah.
between 0 and k.
Yeah.
So now since k is less than 2024,
Yes. And
we
greater
have
than. Yeah.
so we have either this is less than 1012
Ah.
or
Okay.
we have at least one of these only. So like by PHP, one of these ranges should have a repeated number.
Okay, okay. This makes sense. I was
Yeah.
missing that out. Okay, now it makes sense. Good. So then we just choose, and this also same, like you just choose the
Yeah,
because of
just use the
bound.
same.
Yeah,
Yeah.
okay. Awesome. Okay, now we do NT.
Okay.
Okay, Pritesh.
Yeah, what is it?
He's already stopped.
No, I
Uh,
have basic results down. I have basic
Okay, what are the
results that is
results?
N
you
is
have
odd.
that n equal to 1 works. That
Damn.
is the first result. The second result is n has to be a perfect square, and sigma n is odd.
How do you get these results?
Okay, because this is odd.
Oh,
Yeah, see, so
Sigma not
if n is
Sigma.
larger than 1, sigma n is equal to 1. So the RHS is actually odd. As the RHS is odd, LHS has to also be odd. So DN is odd. But as DN is odd, n is a perfect square. And then you can expand it and you can check like, okay, sigma n is equal to this thing. And the number of terms in each is like an odd because 2 alpha is even. So like this is an odd number of terms. So the bracket itself is odd. So all the brackets are odd. So you just multiply it. So odd into odd is odd. So sigma n is odd. Yeah.
Okay, I trust you.
Wait, did that make sense?
Yeah, that makes
Wait, did that not make sense? Wait, what part did not make sense?
It made sense.
it does. It does make sense. Chill. Okay, we have order.
Exactly. Like, what do you mean by impressed in life? It's like
Uh,
order repeats, probably like an order hash.
Okay,
I'm like
proof
so
that
sure
n equals
it's
even is
an
very
order
weird.
repeat.
Like, I don't get why that is true.
What?
Proving that n is even is
I
like very.
agree, it is very weird. Wait. Yeah, it is very weird.
basically, we're saying like now we just need some contradiction somewhere in this.
Like, what happens if you take like n equals 9?
N equals
N
9.
equal to
Ah,
Or
okay.
square in general. Like, d of p square is 3, right?
wait,
Yeah. Then like
So
you're saying like
times
3 divides
p
what
squared
is
plus
wait,
p.
p plus
the
1,
number of pages.
which is just true because like it's p and p plus
Okay,
1.
this is false because okay,
But why it's false?
it's false because like
Ah,
this is a
oh,
square, so
it's
this is what?
even. Okay, so we're going to
That
cook
is
that
even,
thing.
so it like it's yes, probably.
Okay,
Wait,
so
wait, wait.
p.
Order is precisely
Yeah.
alpha n.
Why? What? Wait. What
Because
do you mean by alpha and
I mean, okay, so order of p2,
sigma n?
yeah.
Wait. Sigma n does not even divide this number. It cannot be this, right?
No, wait. What I'm saying, wait, why
I
is
mean,
it so zoomed? First of all. Okay, anyway. So if
order has to divide this number, right? So
I'm saying like, so we have this thing, right? 1 is p.
there
So
is a
or
minus one here. There is a minus one
no, you
here,
square.
and
So
this is a
then it
minus one itself.
yeah. So we
Square. Okay.
wait. The square works, right?
Wait.
Or
So this is then positive. If you're squaring it, this is positive, and there is a two here and a two.
okay. Wait, do I want to square or not?
Yeah,
Okay, just trust. It will work.
you probably want to. Yeah, probably. It should.
This
I mean, this looks something that makes sense.
right, and we know like this order is not equal to sigma n minus 1. So not even divide. Do not divide. Otherwise we will.
That is correct. Yes.
So
Wait, but it could have been like the order is like a power of two. The order is a power of two, and like sigma n minus one doesn't have enough powers of two, and when you include the power of two, it gets it.
that implies
Does that make
this two
sense?
equation. This two equation imply that thing, right?
Yeah.
Basically.
So it's like yeah, that it implies that yes.
Wait, so like if any q divides order of 2, then this does not work, right? So
Yes.
so we have like order of 2 has to be some power, like 2 to power k. And
No, it could be like 2 to the power k times the factors of this guy. That is also a possibility. So just multiplied by some constant alpha. Not alpha. Yeah, alpha works. Actually.
okay, wait,
Or
you're
just
saying
a
like
t or an L.
so you're saying this
Why not
does not
alpha? Alpha is reserved for exponents. Alpha is for exponents. Like use t.
no, we will use this term, delta.
Why? Like delta. Like okay. I
We're going
mean,
to let we're
okay,
going to
sure.
latex this. We're going to latex this for sure.
Yeah, okay, sir.
We are essentially saying this
But
thing, right?
2 delta, yes. Yeah, so we can conclude that V2 of sigma n minus 1 is actually k minus 1, and V2 of the order of 2 modulo p is actually k. This is what we can say.
But yeah, and delta divides this thing. Delta.
Yeah, delta divides. Yes, delta divide. Yeah. Delta is just a factor of this, some arbitrary factor. Why is it delta? Like what? Why have you picked delta, sir? Like
Because
what
you're
is
not
this? Like okay, we should get an epsilon. Wait, we have a delta. We need an
epsilon. Yeah,
epsilon.
yeah.
We have delta. We need epsilon.
Okay, can we conditionize this in some nice condition?
Probably right.
So P is any prime, right? Okay, this weird alpha's prime. Okay.
Oh wait, we also should consider the C. Order of 2 modulo p divides p minus 1, and 2 raised to the power k divides this.
Okay.
So that
Oh.
implies 2 raised to the power k divides p minus 1.
Wait, why order? Okay.
Yeah.
Oh my God.
That is good.
That is
Order
good.
divides
That is-
phi. Order divides phi. We should just write that is phi.
Wait. That also imply delta divides by. Okay, fine.
Yeah, delta also. Wait, so sigma n. Okay, wait, sigma n minus 1 and p minus 1. What are their common factors? Surely they don't have many common factors, right? Key observation. It's like, okay, what is key observation in there? This is like the first thing on board.
The key observation is p minus 1 is alpha. Like,
Aye.
total.
Damn. Damn. Easy.
Wait, where? Okay, he's just not there.
Uh,
Okay. So
okay, what do we do? Oh, I'm watching it through that thing. I'm watching it through what do you call it? The Zoom thing, so that I know what people are seeing, and I can like tell you if you're in like some random spot and nothing is visible.
yeah, so I'm just alone working on the problem, and as you can see.
Yeah, big brain, big brain,
Wait,
right?
wait. We know this k, right? So
Yeah.
all k's are fine. Like all p's are fixed, then. Like I mean, not fixed, but like can it divide like p to power k plus 1? Can like p to power k plus 1
What?
divide p minus 1?
Yeah, that's totally possible. Yes.
Huh? Okay.
Yeah, that is totally possible.
Wait. You saying that so 2 to power k times delta is equal to 1 mod p. Do we need delta? Why can't we just remove delta?
Hey,
Come on.
what are you cooking? What? Nahi, bhai, this is false. This is false. What?
So that's
Okay,
literally
this
the
is order. This is definition of order. Okay.
yeah.
That just look okay. I mean, like, this is like okay.
Okay, we have this, and the k is fixed. So all p's are like nice. Like we know the p's some secretive of a p. Can we cook that?
Yeah, some
Wait, did we
black
use this
magic thing.
did we use this condition? We used, right? Or we
Yeah.
used
Okay, we need
all
to
the p.
cook stuff now. Oh wait, so we know the V2 of this precisely, right?
It looks like this
We
like
should be
Mont
able
problem.
to
This is some
want
like
problem.
just order problem now. Yeah, like some
Yeah,
China
this
problem.
is
Like you kind of have like all the PIs have like some kind of form, like
wait, this
you
would
know the
not be
two
China
power.
problem. This would not be a China problem. This would not
I mean,
be.
okay, it's fine. Uh, okay, what more we can have?
Okay, so from here we know that sigma n is equal to like
Sigma.
a times 2 to the k minus 1
You choose K
plus 1.
to be okay.
What?
Okay.
Now we should be cooking, right? Like, we should just be cooking now. Like, since
No, we are G
we're
solving.
missing something, we should just.
Why we cook random kitchen?
Yeah, sigma, this is this. Wait, can I calculate like the V2 of our like sigma minus 1? Is that
Yeah,
calculatable?
you can calculate anything you want. No one stop.
Bhai, like, okay.
No objection allowed.
Okay, wait, what is. Okay, I don't know what that is. Cool.
Peak observation. Okay, wait. Let's just go
I
over. Let's just go over everything again and see do we miss something. key observation.
Hi, these were observations we got in the prehistoric era. Like, they are not going to matter now. We have used them to get better information. Don't go back to like need like whatever prehistoric dinosaur times. Wait, so I need to calculate somehow the V2 of sigma n minus 1 in another manner. Okay, what is sigma n? Sigma n, we know a formula for that, right?
Yeah.
Okay, there is a square in sigma n. No, there is not a square in sigma n. I'm dumb. Okay, it's like
Tell us
product
something new. Tell us
pi.
something new.
Did you know the formula of this thing? See, I told you the formula. Be happy.
Why?
I need the V2 of this thing.
Why we have this? Wait,
I
what?
mean, okay, the V2 of this.
Why is there a minus one?
Why?
Oh, because of
Oh,
this
okay.
minus.
Okay, yeah.
Yeah.
Sigma minus 1.
Are
Okay.
you sure the V2 of this is like not 0? It could be 0, right?
No, we know that it is equal to k minus 1. And I just want to evaluate this in another manner. So,
Okay. This looks smart. You are smart fellow. Wait.
thank you.
Wait. The PIs we know the.
Bro, you're just contradicting yourself.
Oh, we can
Don't
just use
contradict yourself, sir.
LT lemma, right? LT lemma on this.
Yeah.
How
So
will you
cook.
LT this? Like, this is not a perfect power. This is not a perfect power.
No, not. I mean, he meant something else. Like
No, like you use LT on
What?
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 A to the n minus B to the n, right?
Yeah,
Okay.
but you don't have a to the n here.
You have this is n.
No, that is like one turn. That does not matter. And you also have it expanded as a product. So yeah.
Wait, why can't you use it?
What?
Because he says.
Oh, because you need a to the n, right? You don't have an a to the n here. Oh, wait, are you telling me you'll apply like LTE here?
Yeah,
Oh, that might be smart, yes.
bruh.
True.
This is
That might
basically
be
my subtracting this. Okay.
Yeah,
So
okay.
show me.
I always forget the V2 LT formula.
Oh yeah, like okay, we just need
Okay.
to look up mod for that. Yeah, there's no other way.
Wait, no, guys. Wait,
Hey, like
we
it's
we
V2.
we
V2 is
totally
V2
we
is
tot
valid.
no, yeah, we
What will
totally
you do after
remember it.
calculating the V2 of this
Yeah,
thing?
we remember we're just accessing our memory. We are just accessing our memory
Wait,
using the entirety.
my screen can be seen, right? Lama, I just search mode. We totally
Hi,
not
like
look. We totally not.
yeah, totally not.
Wait, I found it. Never mind. We totally not looking at the.
Wait, does he tell in like chapter 6? He tells it in chapter 6, right? The sad case of things.
I put it on Miro. I'm so fast.
Okay, so
It's just this thing minus 1, this thing minus this. Okay, so it is wrong thing.
we have n is
Okay.
odd, right? So this is like not applicable.
Yeah, yes.
Oh,
We just
Why I
oh no, x minus y is no, this is completely applicable, sir. What?
No. What? We have n equals even here. We have n equals odd in our thing.
Wait, are we okay? N is an even. Yeah, we cope.
Wait, but why are you
But like,
calculating?
okay, this we cannot apply because 4 divides x minus y. We don't do that. So we cope again.
We don't know that, right?
Why are we coping two
Wait, how
times?
do you know that?
Wait,
Oh, we
2
don't
does
know
not
that.
divide
We
that
don't
thing.
know.
But what will you do after calculating
Yeah,
V2?
we don't know that if it divides this or not. So we can't do this.
So
No,
we can't
that
take
way 2
off.
does not divide the whole product though.
What?
Yes,
No,
because this is
Devarchan, he's just trying to apply it to this part, not everything. He's just applying it to this part, not everything.
but
Oh
like
wait,
how
no.
will that?
Wait, but I know the VP of that entire thing is just 0. I know that that is odd. That is why I'm trying to calculate the VP.
Hang on, look at this. This is better, right?
What?
Damn.
This is much better.
That's basically what it's.
So basically, it's saying
Okay.
that this thing this is having V2 of 0.
No, V2 of pi minus 1, which is 0. I mean, I told you that it has VP 0. I know that it is odd.
Yeah, so then what are you trying to do?
Wait, what?
I'm
What are
trying
you
to
trying?
calculate the VP of this entire expression in another manner. Because, okay, I know one way to calculate it. It is equal to like k minus 1. I want another way of calculating it. Do you
Ah,
understand it? Like, do you understand what I'm saying?
no, I'm thinking.
I'm just trying to calculate the same expression in two different ways.
Don't worry about it.
I'll then you ask for
Okay, 3 hours. Okay, not too bad. Not too bad. Uh, what we do here? It's very confusing.
I went for water. I got ODA.
Oh wait, I have something.
Can you like try something else? Why did we take the V2 first of all? Like after getting the order stuff.
Because we had that the order divides like 2 times sigma and minus 2, but it does not divide sigma and minus 1.
Okay, yes. Great.
It's a bit confusing because if we going to focus on P, but P's are like the thing we divide Dn, which is very random. And sigma n, it's like you have to somehow relate sigma n to alpha I,
That was correct.
which is again very random.
Have we ever used the fact that none of the primes are 2?
What?
We haven't used it yet, right? Like, have we used the fact that none of the primes are 2? Like, none of the PIs are 2. Is that like a fact we have used till now?
We haven't. Yeah.
Oh wait, we actually haven't used that. Oh,
Yeah, yeah. We need to use that somehow.
what?
But how I want to use it?
I have no idea.
Okay, wait. That's interesting.
Okay, wait. What is another way to get V2? There has to be another way to get V2, right? Other than LP.
Like
But even if you get to V2, okay, so you're going to use the bound of like sum of the prime if two divides, something like that. How are we using
Yeah.
two? Okay, what's another way to get V2?
Oh, we might be using it somehow here. See, when we are emptying it, we need that 2 divides x minus y, right?
Hmm?
Like, do you
yes.
see this? Bro, my Oreos are finished. What will I eat now? Let's start.
Right.
True.
That
See, we need like 2 divides x minus y, so we're probably using it here somehow. Pretty sure.
Okay, I will come back in 2 minutes.
Yeah. Okay, we are actually kind of cooked here. What? Wait, I know that the V2 of this thing is like k minus 1. What would give me a contradiction? Uh,
actually one more thing that 2 to the power that even plus 1 is a sum of two squares, right? So perhaps we can look at like which primes are 4 mod 3 and which primes are like 1 mod 3 mod 4 and 1 mod 4.
wait, sorry, can you repeat?
Yeah, like in the original question we have dn divides 2 to the power even something plus 1. So that is like sum
Yeah.
of two squares. So where you have taken p is a divisor of d to the dn. So we can
Yeah.
like take into cases where p is congruent to 1 mod 4 and when it's 3 mod 4, perhaps. Like 3 mod 4, it would be okay, so we won't have any prime of the from 3 mod 4, right? Or will we?
You can.
No, we won't. We won't.
You can't. Yes, you can't. That is also. Yes.
All are like 1 mod 4, yes. Wait, how does that happen? Okay, so
And
basically, does
wait,
this
is it true that if a prime divides a square plus sorry, this is yeah, go on.
yeah, like so
Go
and
on,
we
go
know
on.
dn product of 2 times alpha plus 1. So wait, does this imply alpha is even or something? What if yes, it does imply alpha
Oh yeah,
is
it implies that alpha is even, yes.
yes, right?
Oh
Okay, so
wait, in fact,
the power of
okay,
4.
yeah. Repeating this, we get that 2 to the k divides alpha I.
Wait, I guess yes. In
Repeating
fact,
this exact argument.
yeah, ascent, yeah.
What? Yeah, you just get like 2 to the k divides alpha I. Okay, now we are cooking. Like we need like alpha I, so we need to like work with this expression. And that is like copium. Nice.
Okay, I got born. Okay. Uh,
You got
what did you cook? What did you cook?
Oh
just
yeah,
that the
we got that 2 to the k divides alpha I.
What? Why? That's false.
Oh no, that is true actually. Because see, you have a number of the form 2 raised to the power 2k plus 1 raised to the power 2k. So we know that,
Uh, Wait, multiply by
yeah,
something, right?
we know that, what?
Wait.
I mean even works.
No, this is divisible by, like
Infinity.
dn. Uh, yeah, dn, correct. So
Okay.
any factor of this could be 1 mod 2 raised to the power k plus 1. That is like a well-known thing.
Yeah, yes.
Okay, any prime of the okay, this is analogous to the result. Suppose that a prime divides a
Yeah,
square
yeah.
plus b square, then the prime is like 1 mod 2 plus 2, 2 times 2 plus 1. So like analogous result here.
Okay, I know this.
It's
Yeah.
like 1 mod this
No,
number. So similarly, it is 1 mod this number. So we get that 2 to the k actually divides alpha.
wait. So any divisor is of this type, right? Okay.
Yeah,
So
any divisors of this is of this
but
form, and then this is
we also have this, right? Like if P divides this multiplication, then P is of this form. Like 2 to the power
which
k
form?
divides P minus 1. We
Yeah,
have 2 to the power k divide P minus 1. But
p is 1 mod 4, right? So that means that p is 1 mod 2 to the k. Oh, right. Yeah, that is what I just wrote down, right? It is just like 1 mod 2 to the k. So you
yeah.
just get like this is divisible by this. Okay, now what? We need to again VP or V2 somehow.
Okay, so you got something on alpha, which is key.
True. Okay. Hi, how do we calculate V2? Like surely, okay, wait, sure. Surely there is a better way to calculate V2, right? Oh, okay. Yeah, this might work out. We look at sigma n modulo 2 raised to the power k plus 1. K plus 1? Wait, what is the VP of sigma n minus 1? V2. Wait, where is it lost? Okay, it is
Sigma
k minus 1. So we look at it modulo 2 to the power k. Yeah, we just look at it modulo 2 to the power k. And we want to show that it is something bad. Practically, this is not congruent to minus 1. Right? This is all we want to show.
Okay.
Now, okay, but this is also congruent to the product. Oh, now we can maybe VP this. Equal to the product pi
Wait,
minus 1.
why practically
Yeah.
you want to show this?
Oh no, this is forced. This is forced. See, you know that V2 of sigma this minus this is k minus 1, right? Ohm down here.
Yeah,
You know the
I wrote
V2.
above. Yeah.
Yeah. You know this.
Yes.
But this is actually
Yes.
not just a mod condition. This is a V2 condition. If this thing, okay, this is a plus 1 as well. Yeah. If this thing also holds, then you would get that,
Yeah.
then you'll
Yes.
be like forced. Yeah, like you'll be forced that if it is
Yeah, I get it.
congruent, then you would get that sigma n minus 1 is divisible by 2 to the k, which is a contradiction. I'm
Okay, so
getting things interesting.
it's not equal to 1.
It's not congruent to plus 1. Yes, it is not
So
congruent to plus.
it has to be k minus 1 plus 1.
Yes.
Yeah, something. Yes, it has to be that.
Wait, k minus 1 plus 1? Yeah. So we get sigma
Yeah.
n. Now can you do mod k on this multiplication table? Yeah, beautiful. Okay,
Wait, so like,
what are the PIs? Okay, PIs are random things. Oh, so wait, this P and okay, yeah, this PIs and this PIs are different. PIs are
wait,
numbered.
this was, hi, this is minus 1. I was not coping. This is minus 1 only because like you take it there and you get a plus 1. Yeah.
Yeah. He was coping. No,
True.
no, sir. Wait.
I was not coping. You were coping. You were
Sir,
coping.
sir, wait. That imply like you literally saying like this is implied this is -1 mod this. Stop.
No, this is not congruent to this, right? This is congruent to -1. Because like you have sigma and wait, do you have sigma in +1 or -1? Yeah, I am coping. Okay, I got it. I'm coping. It's okay. It's okay. It's okay. It's okay. I am coping.
Don't lose on NT. NT guy, we want you.
Yeah. That's a good idea. I am not anti guy. Otherwise, anti guy. Technically, he should
Otherwise,
be like
NT guy.
coping
Otherwise, should
anti guy.
carry us.
No, I'm
Otherwise,
just copying. I'm a
Yeah.
copy.
Otherwise,
no,
start.
sir, carry on NT, sir.
Yeah.
It will be hilarious. Okay, fine. We're still not coping. It haven't been that much time.
It
Just
will
till
not
like
first because like P6 is going to be easier than P5.
yeah, P6 is going to be. I don't think it give much hope so. The P5 is only problematic. Huh.
I learned that P6 is just bash, so we can just do it, right?
And I think yeah, like I see like some trick by like easy trick bash in like once like 5 seconds, which like just finish the problem. But we will find synthetic solution, guys. Believe me.
I'll be back in 5 seconds. Wait.
Yes. Wait, other like you got it. Okay, if 2 divides this and n is odd, then this thing holds. Okay, so this is भाई this is odd v2. मैं क्या करूँगा इसका copy हम. Why am I coping so much? Okay, wait. Can I calculate what is like भाई ये क्या है v2 नहीं ये वाला. Can I calculate what is this modulo like that large guy? Is that calculatable? Like this thing modulo 2 raised to the power k. Can I calculate this?
Like general K.
Yeah, I mean
By the
not
way,
generally, just like given all these things.
the K is like the way we define K actually like does not give us anything good. So we need to use fact K, and like another way to use K is like K divides alpha I. And also we use K 2 times for some reason.
Wait, where is the first k?
This
Oh,
is
right.
also
Just replace that with some m or something. It's okay.
yeah happens. I have no clue what this is. Why this is so bad.
What is the problem? Wait, who is Siddharth Suresh? I haven't heard.
He's like another Siddharth Kukul. He's another old person.
He's an IMO from UAE.
Oh, okay.
Hmm.
Wait, IMO from where?
UAE.
Oh, interesting.
He's in Oxford only, right? University College. I guess so. No, not. No, not sure.
I have no idea.
Okay.
This is probably the second time I'm hearing his name.
Then you're not looking at many problems. That's your fault.
That is also true.
Okay. NT.
Wait, I think we can do P6 quicker than we can
No,
do
like if
P5.
we know we're
Maybe
going to do
sure.
P6. Like there's no point of like getting like dopamine for no reason at all. Just do NT, bhai.
Maybe the dopamine will
What
help
is,
solve the end.
yeah, just read the problem at least. Let me read the problem.
No, no, don't. Wait, how much time we
Wait,
queued? Oh,
like
wait.
3 hours 15 minutes now.
No. On this problem, I mean. Okay, half an hour. Bro, let's give one more, like half an hour try.
Lines one,
We need some more ideas.
two.
Bro.
I don't know, just some weird cook. I don't understand it. Okay, what would be nice? Let's just look what would be nice. So we know that sigma n is not congruent to minus 1. Sorry, plus 1. I should not go. Right, sigma n is not congruent to plus 1. That is good. Now we have sigma n is congruent to the product of pi 2 to the alpha I plus 1 minus 1 over pi minus 1. Okay, so for the sake of contradiction, can I show that these two things are equal? Mod 1. Beautiful. Mod 1. Okay, mod what? 2 to the k, right? Can I show this? Wait, is it possible to show this equality? Is that a doable thing? Also, Devarchan, do you have any ideas on it?
Wait, am I muted all the time? Okay.
You were. I was thinking, why is no one speaking? Like, why am I the only?
Okay, Devachan, Mandar asked you idea. You should get.
Yeah, what? Okay. I
It's
have no
not like
idea.
I'm forcing you. It's not I'm forcing you or anything.
I was saying, this may be doable, but you never know. Like, it might not be doable. Because see, PIs are odd. So this is like even. So you have even in denominator, even in numerator. Can you actually wait, so you can use LT, right? LT. Wow. Hmm.
I can't, bhai. LT only gives me that this term is odd. That is what LT tells me.
No,
So go to God.
no, like write it like this, okay? And now you want to prove this product is equal to 1 mod 2 to power k, right?
Probably. I mean, if that is there, then we are done. Yes. I don't know if this is true.
Okay, now you can cook. Now you can cook this easily. Uh, how? Wait.
Okay,
Alpha is
wait.
multiple of 2 to power k, right? So
Yes.
you
It
can
is
write
just
this
like,
there's a pi.
bhai, there is a 2 here as well. There is a 2 here as
Wait. Then you can just like use some mod. Like this should be like this 0. Like some. Wait, doesn't this result hold?
well. Oh, wait, that is extremely smart. Yeah, we should be, okay, wait, we should totally be able to cook it. Yes. So you just look at this. So that
Oh,
is just this thing minus this thing, which is
Wait,
just
did I just
pi times.
did I j-
Yeah, you
did I
just
just
cooked. You actually just cooked, bhai.
did I just cook
Yeah, you
NT? Oh
actually
my
just,
God.
yeah, you just cooked NT. Yes, that is true. Now we take the V2 of this guy, then that is just the V2 of pi 2 to the alpha I minus 1 minus V2 of pi minus 1, which is just equal to the V2 of भाई वो फॉर्मूला क्या था I forgot. uh pi is pi plus 1 okay, pi plus 1. No, you'll have a plus 1 here, bhai. Like, why are you cooking?
Ah, trust. Wait. Why you what is this? Like, is this like V2 of
And then you just have an n by 2, right? Yeah. So that is just like, wait, then you don't have this factor here. And this is like,
Wait, this is at least k.
okay, pi plus 1 is, this is strictly larger than k, in fact.
Yeah, yeah.
Not at least even, it's strictly larger than k.
So it's done, right?
Oh, so like this is 0. Oh, so we are done. Like, yeah.
Wait, show. Wait,
Bro,
this is not.
cooked it.
I know this. Still, like I.
Okay, we are done. Like,
Okay,
Wait,
now summarize.
you can do this way also, right? Like this is true, and so this is multiple. So this is also 0. So everything is just one mod.
nahi bhai, this is true. This thing is true only because this thing is true. Like you can't directly get this thing.
You can get this thing. Trust. You just use what
You can't.
primitive root, sir.
By the way, you don't even get this is 0. You get that this is 1. You don't get that this is 0.
Okay, one and two are one and complement. Same thing.
1 is
Can
0
you-
approximately.
Yeah. Wait. Mandar. This
Oh,
thing
yes,
is
they
this.
were saying, you are saying something.
Yeah, like, can you explain this part?
Yeah. This thing is the same as this thing. These two are the same thing. Sorry, Devarchan, what are you saying?
Yeah.
Wait.
Okay,
What?
just VP.
Mandar. This
Oh,
is an
you want me to repeat? Yes. Okay. See. So
Okay,
see, by ohm the ores, bro, ohm the ores. It's a nice name. Okay. So we want to show that. So the point is, do you people see that if we get that this thing is congruent to 1 modulo 2 to the power k, then we'll be done.
wait.
Correct?
All product. All product are only this thing. You're not
Yeah,
taking
it's
all.
for a general p. This is like for a general.
Ah,
Yeah, this is
okay,
for a
sure.
general p. This is for a general p. Yeah.
Yes.
So now is the hardest part. We do arithmetic and we cancel the ones. Okay, do you get
Okay.
it? Arithmetic. It's hard. It's hard. I agree, but so now the statement is equivalent to this is a GP formula. So first term, common ratio, number of terms plus 1 is just this minus 1 divided by common ratio minus 1 is congruent to 0 modulo 2 to the power k. So now all we do is we calculate the V2 of this term and we want it to be at least k. Correct?
Yes,
Does that
Okay.
make sense?
it does.
Ohm, does that make sense? Ohm and divergent both. Yeah.
I solved the problem, right? Yeah.
Yeah. Okay, see the issue with this is okay, the issue with direct computation is actually probably nothing. It will probably just directly be computable actually. I'm coping.
Yeah, it's fine.
Uh
This is acceptable. I agree.
oh no, okay. The issue with this, like, okay, we can't directly compute this product because it's a horrible thing, and we can't directly compute this thing because like the denominator issues, right?
Wait.
Yeah.
But while
See,
you
the denominator
computing
is
the
even. Do you
VP,
see that the denominator
wait,
is even?
yeah.
Of course, yes.
Yeah. See, the issue, okay, so the issue with direct computation, sure, we can compute the VP of the top directly, but the VP of the bottom is somewhat like V2, okay, we want to show that this is 0, so we want to show that the top is 0. But the top, we know that it is already 0 because like odd minus even is actually even, which is like, okay, sorry, odd minus 1 is even. Okay, this is an odd number, minus 1, so it's even. And now we also know that phi of 2 raised to the power k is actually 2 raised to the power k minus 1. So this is actually 0 modulo 2 raised to the power k as well.
All right.
But the issue becomes, that the denominator might have a huge power of 2.
Hmm.
Okay, that is possible, right? The denominator can have a huge power of 2.
Right.
Mandar,
Not irrelevant
okay.
anyway.
What?
Like
We are
speed.
done, right?
Yeah, like we have this is
We
equal
are just
to
done. This just finishes. Yeah. You just
Yeah.
compute the VP and you're just done. Yes.
V2 of P to the 2 alpha.
Wait, can we skip the VP computation? Is my
Sir, let it be there.
question.
Okay,
We
like
need VP computation to like have like alpha, 2 to power alpha greater than k.
Yeah, that is probably true,
If you
but
just
we
go
should be
to
able to skip it in a meaningful manner, right?
we're just
No.
done. Like there is no computation.
Yeah, there's no computation. Like
I know there is no computation, but like I don't want to do this. Like, can I
no,
directly argue by modular arithmetic instead of periodic evaluations, like like VP stuff? Can I just like directly argue by
Why
it?
do you
wait,
want
wait. I just got OMC comment. We don't care about all modular arithmetic. Let's just move on.
I mean, like, okay, like, sure, that is true. We don't really care about them. That is indeed true. Uh, that is a little cool. So,
I mean, okay, so
hmm.
you're saying like, can we directly claim this? But we need to use fact that alpha divided by k, and then we need to use the
Oh
thing
no,
that it's also
you use that. You use that. See, you get that phi. Oh, okay. Yeah, I don't think
and
you can directly comment about this
yeah,
just using modular arithmetic.
yes.
You
I
just
mean,
can't do that.
this is fine. Like this is also beautiful. Let it be. And this was nice cook actually. I like
No,
this
the
problem.
issue is like pi minus 1.
Yeah,
If you
yeah.
did not have pi minus 1, the numerator is directly divisible by this. We know that. Because of this fact, this is like not 2k, it is 2 to the k. Yeah. Like, as 2 to the k divides this thing is directly divisible by 2 raised to the power k plus 2 actually. 3. Damn, it's divisible by 2 raised to the power k plus 3 directly without even using the VP of pi minus 1.
Is this V2
Which is
correct? What
insane.
this Atharva wrote?
Wait,
This
sorry,
one.
what?
Like, is this thing correct? I'm not sure. Because
Yeah, this is correct. Yeah,
it
yeah,
went
that is
all
correct.
right.
no. So this comes out
What?
to be alpha I minus 1 plus alpha pi plus 1 plus
Yeah.
pi minus 1. No, all right.
Minus
2.
1 nahi, minus 1 nahi aata.
Minus 1 is there.
This is
Like,
just like,
sir,
okay,
minus 1,
sure.
yeah, like there's
No,
a
there is
minus
no
1.
minus 1,
Sir,
sir. There
look,
is no minus 1. Your
look at
alpha
here.
i's were, brother, wait. I will tell you why there is a minus 1. Because see, their n remains an n, right? They start with an n and they end with an n. We started
Yeah,
with
yeah,
2 alpha. We started with 2
yes,
alpha. We started
yeah. So there's no minus 1. That's what I'm
2
saying.
alpha. You
Yeah,
see, there is no minus
there's
1.
no,
That is the point. Yes.
that's what I'm
And then
saying. Yeah, yeah.
this yes. Then this thing and this thing cancel, and then you get that this is at least this thing, and then that finishes.
It's key.
Okay,
Okay, so we are done, right?
but
Okay,
okay, yeah, I
so
don't think there is a. We were done like 10 minutes ago, but I don't think we have a way to do this without VP. Is the issue.
sir, why you have problem with VP? We use order, so VP is fine too. I like this problem. Come on,
I'm
stop cook.
okay.
Who
So who's
explain?
explaining the solution? I'll like try to 6.
Okay, so I will explain. Sure.
We should totally MMP at least one
Yes,
something.
Oh,
yeah.
MMP. Wait, why? How you
Wait,
MMP? Okay. Yeah,
go that. I'll just explain this. You can go that. Oh, yeah, like I'll just
I will
explain
just
this.
solve it immediately. Like, okay.
Oh, that's
Uh,
also possible. Okay, do you want to explain? You can explain as well.
yeah, you explain. I will just
Fine.
interrupt you in between. Yeah.
Yeah, just solve P6. Solve P6 to that. Okay,
No,
so
I have to share
key
screen with you.
realization.
So I have to share screen with you. So you explain. I will just watch you dance.
Yeah, key realization. D of 1 is equal to sigma. That looks like a 6. Sigma of 1 is equal to 1, which implies 1 divides 2 raised to the power 1 minus 1 minus 1, which is 0, which is equivalent to 1 dividing 0, which is a true statement. So we get
Bye,
that
bye.
the hardest part of the problem is done. Yeah,
Okay.
the hardest part of the problem is done.
Otherwise, others
Now,
left for readers to.
suppose. Yeah, like yeah, the other part is left for the readers to complete. Now suppose uh that dn divides 2 to the sigma n minus 1 plus 1 observe
Observation.
that sigma n greater than 1 for all n larger than 1. That implies 2 raised to the power sigma n minus 1 prime plus 1 is odd, but that implies dn is odd, and that then implies that n is a square. Okay. Yeah. Wait, there are factors of 2 everywhere. Thank you.
Wait, when did we use the fact
Now
that
we get
2D?
that
Okay.
the fact that
When
what?
n is not
Wait, what?
n is not even.
Even while calculating the VP, like you can take the V2 because it divides x minus y.
Okay, I will just
Wait,
remind you.
I'll get there.
Yeah, you will get to that. Okay.
Yeah, that's a great. Yes. So now we get that summation. Okay, dn is equal to summation 2 to the alpha I plus 1. The summation is over I. Sorry, the product is over I. And you get that sigma n is equal to the product over I of p to the pi 2 to the this plus 1 minus 1 over pi minus 1. Okay. Now let p divide dn. So that implies p divides 2 to the sigma n minus 1 plus 1, which is equivalent to saying that 2 raised to the power sigma n minus 1 is
We
congruent
don't
to
need.
minus 1 modulo p.
Okay, we need p.
By this I mean
P.
modulo p.
Yeah.
Yeah. Which is equivalent to saying that 2 raised to the power 2 sigma n minus 1 minus 2 is congruent to 1 modulo p.
Yes.
Now, wait, but that implies, okay, I need to write a better R. Hi, my stylus. Okay. Order of 2 modulo p divides 2 raised to the power sigma n minus 2. And order of 2 modulo p does not divide sigma n minus 1. But that forces order, so the v2 of the order of 2 modulo p, if this number is k minus 1,
Minus
the
1.
v2 of sigma n minus 1. Okay, wait, this is like, okay, wait, I quote. If this number is k, then the
Yeah.
v2 of this is precisely this thing minus 1.
Main
Also,
fact.
yeah, this is actually the main part. This is the main part. Yes. Now the next
All
thing. Okay, I forgot what
devices.
the next thing was.
All devices are
Yeah, yeah.
actually like.
See.
Okay.
Sorry, what were you saying?
All devices of this thing, what DIs are actually like divided by k, like 2 to the power
Yeah,
k,
yeah, yeah.
right?
Yes, yes, yes. So the next thing that we get is actually okay, I totally forgot what is the next thing. Yes. P minus 1 is divisible by 2 raised to the power. Okay, wait. We should write
So
it in more
wait.
detail. 2 raised to the power k
No,
is divisible
okay.
by order of 2 modulo p, which divides p minus 1.
Yeah.
That implies p is congruent to 1 modulo 2 raised to the power k.
Yes.
Yeah,
Yes. Quick.
nice. So, okay. But this also implies that alpha I have to be congruent to 1 modulo 2 raised to the power k minus 1. Right? Yeah, this is forced.
Wait.
Because if this was not the case, then okay, this is because you have the product of 2 to the alpha I plus 1. If it was not 0 modulo this, then like the product here would be disturbed, and hence like you would get some factor which is not 1 mod. Does that make sense? Like, or should I explain it better?
I mean, you can explain in like this. Wait, this is what we did.
Oh
Like, I
yeah,
think we
okay.
did.
Suppose that this is not. Okay, no, this is actually what we did, I think. Oh, okay.
No, but like, so
No, yeah, this is
here,
what we
like,
did.
here,
Yes.
here we're considering P, right? But like this alpha is like, you're assuming like P divides like,
The product. P divides this product. Yes.
yes. So how you get like this?
Oh, oh, right. Yes. See, P divides this product.
Yeah.
Okay, wait. Replace P with Q everywhere because I need to use a bunch of stuff now. So we will replace P with Q
I,
everywhere.
I mean, this argument was bit, I mean,
Uh,
same, I guess. Quicker, I guess.
Wait, I think that was false.
That was false. Okay.
Wait, this argument, right?
Yeah.
Oh yeah, this argument I think it is false. You can only get, okay, the point is you only get the information about the prime factors, right? You can't directly derive the fact like information about the factors themselves. Do you see that?
Yes.
From
Yeah.
this
So
we
how,
derived the fact that the primes are actually one mod that, and then
yeah.
we went on to alpha i's.
Okay.
See,
So how
you
we,
have this is this, all the primes are like modulo this.
yeah.
Now uh, you can write this as some q1 to the beta 1, q2 to beta 2, so
Yeah.
until ql to beta l. So this would imply that 2 to the alpha I is equal to like some q I1 beta I1 dot dot dot. Okay, I agree,
Wait,
horrible
what?
like notation, but this is the best we have. Oh, this is in plus one.
Okay.
There is a plus one, sorry. There is a plus one. I'll write that better.
It should be like TI.
2 to
Yeah.
the. Oh, yeah. Okay, you get this thing. Now, observe that this term is like congruent to 1 modulo 2 raised to the power k, because all of the QIs are like 1 mod 2 to the k as
Terrible.
we showed before.
This is terrible proof, but anyway. Okay.
I agree, this is terrible proof. So this
So
would
you
imply
get
that 2 to the alpha I is congruent to 0 modulo 2 to the k, which is implies that alpha I is actually 0 modulo 2 raised to the power k minus 1. Yeah.
we had a K, right? Not K minus 1, but
So
okay.
this is
I
what we
think
have.
it. Oh yeah, it should work. It should work. Okay, yeah. Okay,
Oh,
we
that
get
is like
this.
computational error.
Yeah.
A
Yeah,
small
this works.
computation errors. That doesn't matter. Okay. Now we look at okay,
Okay, now
claims.
we use
Now
the
this is
fact
our
that this is
main
K.
claim. Yeah,
Yeah.
exactly. Now our claim is that 2 raised to the power k
Yes.
divides 2 raised to the power k divides a. Why am I writing a again? Yeah, like what is this code? P raised to the power 2 alpha I plus 1 minus 1 divided by p I minus 1 minus. Yeah, this is our claim, right? Yes,
Yeah.
it is. Nice. So,
This can be
uh,
trivially done.
observe that.
V2.
Yeah, obviously, obviously.
Just start with V2.
This
So
is
V2 of
equivalent to.
plus.
No, I won't start. But I won't start with V2. I want to simplify this expression first a little bit. This divides pi p to the 2 to the alpha I minus 1 divided by pi minus 1. This is just algebra. You just like take LCM and divide.
Take LCM
Now,
by. It's like
the
minus
V2
1.
of this. Yes, yes. So the V2 of this
Yeah.
quantity, P2 to the alpha I minus 1, is equal to the V2 of, there's an I here, this thing plus 1 plus V2 of Pi minus 1 plus V2 of alpha I minus V2 of Pi minus 1. So you can just cancel this thing and this thing. Wait, what?
I'm just writing. I have no. Okay, yeah.
Oh, okay. Wait, we should write this on the top, right? I'll just move it.
No, it's fine. Okay, sure. It's fine.
Oh, okay, sure. I will just like keep writing on the left. Then this thing is okay. Observe that we know that this thing is at least k minus 1 because we showed that alpha I is at least alpha I is
Yeah.
0 modulo 2 to the k. So from this we can say that here we apply this and okay, pi is odd. Here we are using the fact that pi is not equal to 2. We are using the fact that pi is not 2. Be happy.
Yeah, okay.
Okay. More importantly, when doing this V2, we need to make sure that 2 does not, okay, sorry, 2 divides pi minus 1, which is equivalent to pi not equaling to. So this is like the place we have used that the number is actually odd. That is like one place we use it. And then this is strictly larger than k, sorry, greater equal k. But that implies that sigma n is congruent to the product of p to the 2 alpha I plus 1 minus 1 divided by pi minus 1, which is actually congruent to 1 modulo 2 raised to the power k, which then implies that sigma n minus 1 v2 is greater equal k, which is a contradiction as we know that the v2 of sigma n minus 1 is actually k minus 1.
We are done.
So that's a contradiction and we're done. Yeah. Bhai, like this was such like okay, there is one place you use it and it's the tiniest detail ever. Okay,
Bro,
great
this
problem.
is very great problem. Yeah. Okay.
I
Are we
agree.
ready to like swim the geo 2 seconds?
Yeah, another search like
Okay.
we should be able to do another search.
I mean, okay, so thing I got like the when okay, B1 C1 and M is a perpendicular
Alright,
between
let's just do like one
okay,
solution.
it's-
Like we have a
No,
Wait,
see. So what you want to prove is like
Yeah.
this T point. See, Manda.
yeah,
So MH intersected antipode, right? A dash, and you want to say like perpendicular.
yeah.
So and wait, T is a perpendicular bisector. So like T lie on perpendicular bisector, which also lie on the antipode line. So T is center.
Yes.
Okay. Now if you want to prove T is
Oh
center, which
right,
is
yes.
equivalent to proving this is perpendicular. Okay, 90 minus B. You can
Oh,
chase this length, and like you can also chase this length because this is angle C and this length is also known. So by like just angle length chase, you're just done with the problem.
Wait, what?
okay, let me just length chase it, you synth it on the
Speaker show.
okay. I will just length chase it, you synth it on the side.
Wait, can you repeat what you said?
You are just lecture and then that was my
No, no,
2 second
repeat,
solution.
please.
1 minute.
No.
I was like, okay, what?
But we are not doing it.
No, wait, Tom, can you repeat what you
Why?
said? What to chase?
Okay, so see, we apparently want to prove T is equal to O, right? So
Yeah.
we basically, if you consider this intersection as X, we know this is 90 minus C. And this is like, I can even tell you that it's like B cos A. And so you can just like put it here, like this is angle C. So you can just put again, like this is B cos A cos C. And now you want to add this length. Now we know this length is like what? A cos B half. And now you take like this, you take this cos So this is like divided by cos B, cos C equal to B2 C1. And you just add both of them. And you want to prove this plus this is basically equal to like what? C cos A cos B plus cos C by 2 cos A, something like that, which is basically trigonometry. And you're just done by trig bash. But never mind, we are doing synthetic.
Wait, I will just trick bash it on the side and like because we
No,
need to
you're
present
not. We are
all
not trig
solutions.
bashing. I literally
We
told you
need to
trig bash
present
solution, and we are
all
not doing trig bash.
solutions for why sake of completeness. For the sake of completeness, we need to present all solutions. Right.
Wait, just to share, like, how are we like excluding the possibility that it could be the QA point over here? Like, of course, it's not, but like for completeness, like, why can it not be the QA point?
No, like it's line perpendicular bisector of BC, right? The T point. Oh, wait, you mean that?
Yeah, because
Wait,
like QA does not lie on the perpendicular bisector.
no. He meant like it's this point.
No, he meant that T is equal to QA, right?
No, I meant like, why could the like MH intersects at QA and A antipode? So we are like going with A antipode, but why could it not be that TA and QA are collinear? Like
And yeah,
T,
like what I said. T will be this T dash. Yeah, that will be possibility. I agree.
Boom, that is why the trick bash fails.
I mean, okay, maybe
Wait.
like actually T dash is actually this, like the basic. We need to calculate. Okay, now we need to actually solve the problem, unfortunately.
Wait, dash.
Okay, so we have 90 minutes. This is also 90 minutes.
Wait, can we invert the problem somehow?
Wait, B2 lie on the circumcircle. Okay. Wait, we are just
What?
done. Holy shit, we are just done. Oh my god,
Okay, I
we don't
don't know.
even need to.
Bhai, I don't know what you cooked. You just cooked whatever you want. So your claim is B2. Okay, wait. If B2 lies on the circumcircle, then like
Just. Okay, look at this. This is the diagram, right?
bhai.
ABC circumcircle.
Yeah.
Guys, this is solution. Very
This is solution. Okay. You know, problem 6 and problem 3 took us the least time overall.
Okay, I know.
that is-
Okay, so ABCD.
Aye,
and
wait.
the
B1 and C1
name
are
is there.
not those. Sir, B1 and C1. Okay, they are correct. Yeah. Then what?
Wait, they are.
They are correct
Actually,
only.
like, am I wrong or am I right? Yeah. Okay.
Wait, are you sure you're not just
Yeah,
like
stop.
hallucinating?
Okay.
Okay, sir.
So
Trust me.
I claim like, okay, suppose like you consider this B2, right?
Yeah.
Oh yeah, this is
Yes.
B2. So now I claim B2 lie on ABC. Okay.
Okay, if that is true, that would be so sad
So
because that is a
notice
very
like this is
rational
perpendicular
statement.
bisector and this is angle C. No, listen, Mike, listen. This is angle
I
C, this
agree
is
that
angle
is
C,
angle
right?
C, yes.
This is perpendicular bisector. So this is also angle C.
What is perpendicular?
Wait, why is it perpendicular bisector?
B2
True. Wait, but that
because
does not.
because like this
Okay, that is
circle.
perpendicular to this and okay, sure.
So
Wait, no,
that
I
means
still don't see why it's the perpendicular
tangent
bisector.
to
Wait. Listen, M is the same thing circle passing through B, C1, B1, C. And like we draw from perpendicular from M to AB.
Oh, okay, yeah. Okay, I get it now.
Perpendicular
Yes,
bisector of
I get
BC.
it now.
Perpendicular bisector of this. Did you get it, Devachan?
yes, but that means B2 is like tangent to ABC, right?
What?
Yes.
No. Oh yes. Never mind.
No.
My name was long.
Okay,
I mean, okay. We still got something.
Yeah, we got
Still-
something. Okay, we got
Okay,
one.
my bad. I'm sorry.
Blue is like, okay, I am done with the problem. Okay, nice.
My bad. Okay.
Wait, but this is still a very bashable problem. Like, I would not.
But yeah, we
Okay, wait,
got
is it
something nice
bashable?
about C1, right? I mean, okay, so B1 is like tangent. C2 is tangent. So I'm going to draw this. So very good diagram and beautiful.
Yes, yes, beautiful diagram. Beautiful. Wait, so we just want to show that that intersection is the midpoint of B to C2, right?
Yeah.
Okay, that is interesting.
That should be doable for Manda.
What?
This should be doable. What I thought was like this angle is C and this one's angle C, so like you can see. Never mind. We can also equality to showing that.
Wait. Okay, wait. Is it should okay? See, the intersection point X is like the in triangle A1, B1, C1. It's the X touch point, right?
No, it's the A alternative.
No, in the orthic triangle. In the orthic triangle,
Okay.
it's the X touch point. Wait. Hi, now we can trick bash this. Like, why are we coping? That trick bash was hard.
Okay, listen,
Trick bash is
Manda.
not hard.
Listen, Manda. If you call this like, suppose like, name PQ, okay? Then what you want to show is like, B2P is equal to QC2, right? Because
Yes.
O is already line
Yes.
perpendicular to PQ. Yeah.
Yes.
Now that's equivalent to showing like
Yes.
B2P into B2 Q is same for both of them. Because this is basically
No,
adding
wait,
some
why is that
PQ,
same?
which is
Why
constant.
is it equivalent?
You're saying like X plus PQ plus X has only one solution. Okay, never mind. That might be true. I thought
Okay.
because like if we just show like power, so okay, like I want to just say like so B2 and C2 have same power. Wait, that's just true. Okay, B2 and C2 have same power with respect to O, right? We just want to show OB2 is equal to OC2.
Yes.
And
Yeah, that
we
is
know
true.
angle B2BO is 90. And we know OB is
B2B.
R.
Yes.
So we want to show like
Oh wait, so this is like cyclic quadrilateral as well.
no,
Wait,
wait,
that
what is
is-
like yeah, but yeah, like in one X is
B2XOB. B2XOB.
yeah, in one X is hard, but we want to essentially show this, right?
True.
The congruency. And so to prove congruency, we just want to show BB2 equal to CC2, which can be now, as you said,
Like
yes, it
okay,
can
yeah,
be
we
like
should trick bash it. I agree.
there's no trick bash, but there's like just substitution of the definitions.
Lengths. This is lengths. This is not bash. This is not bash. I agree.
But I don't still I don't agree.
Wait a bit. This implies B2C1 is equal to C2B1, right?
It should be. I think so. I hope I'm not making mistake again.
B2C1.
But that means
I
we
will
have
try.
Wait, that is okay.
Wait,
this is
that's
equal to B1 C2.
so bad. That looks so bad.
But that implies
Like
A of
just oh no, that is just true actually. That is true. Wait, that is true.
that is not
But why
Your
this
thing
looks
is
so
true.
bad?
Like this length is no. Uh, yeah. This length is equal to this length. Like B2C1 is equal to C2B1. That is true.
from
B2
here.
Wait, no, that should not be true, right?
Yes,
Wait, that should not be true.
No. Sorry,
Wait,
that should not be true. That should not be true.
why are you making so many false claims? I
Wait.
have a copy, so have I.
Yeah, exactly.
Like
Just
this
90.
actually gives a contradiction, right? Because it implies A1 means AO bisects B1 C1.
Yeah,
Which
yeah,
is
yeah, yeah. Yeah, this
Yeah, that is false, certainly. But see,
something.
oh, look at this. Oh, look at this.
tell.
B1, B2 C1 is like,
Not tangent.
wait,
Am I
it's this thing
copying?
by cos. Okay, I'm coping. No, I'm coping. This is like
Like,
this thing by cos.
yeah,
Wait,
it's
they're not
by
equal.
cos.
They're not equal.
So what's the mistake there? I'm so confused.
Exactly. So, oh, it was like, nahi, bhai, there is no mistake till now, at least in my bash.
What?
Uh,
I will realize this.
okay.
Wait, but like, what was the mistake here? Like, we say we
What?
want to show this only, right? Or no?
Yes.
Yeah, if you have that, you are. Wait, why are you done if this is the case? Because O lies on the perpendicular bisector. Okay, yeah, that would match.
Probably so
Yes.
that the O does not lie on perpendicular vector. It's probably the point Devachan was talking about, like this Q, maybe.
Wait, but that is like impossible, right?
What? Like this can be possible. Right?
How? Oh, okay.
Yeah, like because if
Yeah.
wait, we just proved like if O is possible, then we get this claims, which
Which
implies
is
like
wrong. Which is wrong.
it is wrong.
Wait. Like, why is this wrong?
So like this, if this is true
B.
and this is true, then we just imply like B2.
B2 lies on the. Yeah,
Yeah,
exactly.
Hmm.
okay, might be like
Yeah,
this is like
that
other.
is false.
Wait, but if this other thing is true, we are just like overcooked, like so bad.
Yeah.
Okay, maybe actually Anand sir cooked some actual geo.
Let's cook some actual Geo. Like, what has he cooked till now?
Wait, this is parallel. And wait. We know like this angle is equal to this angle. So, oh no, never mind. How did I got the wrong claim again? Bro, I'm getting so many wrong claims today. What is happening to me? Some weird homothetic. Bro, why? Why tea? No, I don't want to cook tea. Okay. So these angles are 90 minus C, 90 minus B. Where have we seen this? Okay, 90 minus C, 90 minus B. Those are not perspective. Surely not.
So we want like TB2 equal to TC2.
Be sleepy.
That's hard. Yeah, I am sleepy. Yes. Wait, TB2 equal to TC2. How do we do that?
We can actually now like do inversion about M, which is quite fascinating.
Oh, interesting. How do you? Okay.
Then this will go to like the perpendicular from this to T will go to here, T dash.
Wait,
But
how
wait,
will T
is
go
T the
there?
actual good center? But I want to say is T actually good center? Like
Wait, how
is
will
it
T
actually
go there? What?
constitution? Because like no, it does not go. Yeah, it goes there because this is 90 and this is 90, and Q goes to K H.
Hmm. Oh yeah, it goes to that. Yes, that is true.
Right? Okay. Um, Still I don't like this, but I have no option.
I mean,
Bro,
I agree, but we need to solve it, right? We need to solve it.
fix all. I am just like sad now.
Yeah, like it's okay.
This
Blue
one is
face
very confusing.
solved twice. The same problem. Skill. Wait, should we just like bash it out?
No, like that won't be a
Should we
fun.
just bash it out?
No, that won't be a fun
Okay.
again.
Okay. Okay,
Oh,
sure.
wait. So essentially, you want to show. Wait, this is midpoint, and these two are parallel.
Wait, can't we write this in terms of like some involution? Not involutions, I mean concurrencies. Because see, we have this line, and that line. What if we extend the perpendicular bisector of B2 C2 to intersect the circle at 2 points again? Does that make
Is it the
sense?
circle?
Should we do that?
No. I mean, does not make sense.
Okay.
I mean, what you said, I could not listen properly.
I was like, we need to show that three lines concur. So like involutions. That is a way to do it, right?
Yeah.
But the issue is, okay, I don't know involution is the only issue. I don't name it T again. Who's naming this T?
No clue why.
Don't name it rather.
Not me. Sure.
Yeah,
Okay, so
certainly, certainly.
we just do it's not O, so it's not even trick by sugar. Apparently what I heard is uh I can't confirm from one of the person, but like three people of the team just complex bash this. It is quite sad.
Oh, damn.
Complex or
Yeah.
complex or trick bash, which is quite
We
sad, but
can
I can't say anything else.
complex.
Shut.
I
Okay.
can. I think we can complex this. Yes. Do you want me to complex it?
No.
I'm pretty sure I can
Thank you.
complex this. Why, bro?
Yes.
Like trust.
I'm pretty sure you can complete this, but thank you. No need.
Okay. Okay.
It's 90 minus C. So this will be 90 minus C. What is 90 minus C here?
Ah, okay. How do we even look at T? What is T? Hmm.
Okay, this is 90. If we actually consider circle passing through those points, is it exactly possible?
Wait, this is just these are parallel lines, right? Uh,
Which?
what is this? MB2 is parallel to CC1,
Yes.
Oh,
and this is parallel to this. So this is their homothety center. Let's call it Y.
Okay.
Okay, where does this homothety map?
oh damn. Oh, I was finding some homothety. Wait. That's cooked. So we need to show in that homothety. This will send to this line. T dash. So homothety sending M to H. So basically like this is what?
Hi, T won't go to
Solution.
that line. Why will T go to that line?
No, obviously not. What are you talking? Oh, wait. We're done, man. Ah, yes. Happy New Year.
Crazy cook again.
Okay.
Some weird crazy cook.
So first of all, like, see, if we're taking that same homothety, T will go to something on AH because like TM is
Yeah, correct.
perpendicular to B.
I understand. Yes.
Yes.
So it should go to somewhere on this. And now we just want to prove this is like center. This is like N, the ends. And then we are just done because then it should be midpoint of this thing. So C1,
Okay,
B1.
can you
And it's
please
back.
translate that to translate that to human or English so that like the viewers as well
Okay.
as us normal folk can understand.
Okay, you can call this center
Yeah, go
Y.
on.
Notice that Y is the homothetic center of sending C1H B1 to B2M C2. Now, if you consider this point T,
True, true.
which is like then TM is parallel to AH. So M go to H, then T has to go to this intersection point. Call it N. So we have T go to N, and if we want to prove T is the midpoint of B to C2, like lie on perpendicular bisector B to C2, we equivalently want to prove N lie on perpendicular bisector of C1 B1. But do you know AH is the diameter of this circle, and
Okay.
perpendicular bisector,
Yeah,
so
yeah,
N
yeah.
is the center. So
Wait, why is
T
N
is
center? I don't see why N is center.
like we want to prove N is center. We want to prove N is
Yeah,
center.
that is true.
Yeah.
We want to show that N is center. Then
No, N is the center, right?
And now we just remove. Wait,
nahi,
there
and
was
we don't know if N is the center. If N is the center, we
okay.
are done. If N is the
Yes.
center, we are done. We don't know if N.
And now we just reduce everything
What?
in terms of this, like Y and T, right? B1, C1 are
Okay,
gone.
so
So
wait,
we are
you were
just
done,
done.
right? How is
No, I'm saying, I'm saying like we just shouldn't have done. We should be done.
okay? Yeah. Should fake solve. We should have a fake solve count.
No, no,
Yeah.
I picked her twice the same geo problem in Livesolve. It's like peak focus.
Bro, this is like 3 times.
Wait, I haven't. Oh, actually, I say almost like we are done. Okay, I never said we are done. Okay, I just was explaining to you.
You did say you are done. You did say we are just done.
Three takes. Three takes. Oh wait, essentially we want to
Nice,
do
nice.
this is collinear. So this is some orthic. There are so many 90s. You're dropping 90 from this. You're dropping 90 to here. So this concurrence. What? This doesn't make sense. Okay, wait. No. Okay, 90. Uh, uh,
Look at this. Look at this. See, observe that. What do you call this? Okay, wait. Let this intersection be like HA or something. Then QHABC is -1. Okay. Project that onto like this. Project that onto this line. Okay, no, that does not work. I'm done. Okay.
Right. Tell us something new. Sir.
I don't have anything new to tell, sadly.
I hope no one listened.
Sorry. So probably everyone did, but it's
Wait, that harmonic, can you send that harmonic to here? Oh wait, that line is harmonic. That's true. Like this, because you remind me harmonic exist. Right.
UHYM. Okay.
yeah.
But yeah, also that one is also cyclic with some stuff. Can we use cyclicity? Can we use Y something nicely? Okay, you can do 2 times.
Wait, do
Why
you think I can
exactly
remember
my
it now? No, I can't remember it
yeah,
immediately.
nice. What is MMP in config question? Like, I have no clue what you guys like.
I also don't.
Why you MMP in config question? It makes no sense. This should be just true, right?
Should be just true. I agree. It should just be true. But it might not be. So, like, yeah.
My brain right now a little bit like Okay, it's fine.
Bro, it's Geo. Your brain should be done with the problem by now. Okay.
Wait, is that 90? Is that 90? Is that 90? No, it's not 90.
Wait, how do we even show that things one
Okay.
per
Yeah, this. Oh my God. This is so good. Okay, you project this from N onto M, from N, M infinity AH, Y goes to T, and M will go to M, Q will go to K, KM. Okay, this has to be -1. That implies K is the
what?
midpoint. Can you see? So this is -1.
K
You project from
infinity
M.
T M. How are you getting an M? How are you getting an M? भाई M कहाँ से आ रहा
M will
है?
stay to M.
Oh, M just okay. M just stays
M
at
will
M,
get
and okay, you're projecting this.
Y,
Okay, so K
y
is
go
the
to T.
midpoint of this. Okay,
Yeah.
okay,
And now
and this
take a
is like
homotherty
90
from
degree
Q.
as well, and this is midpoint.
No, take a homotherty from Q. Same thing.
Oh, okay. Okay, bhai, no, we don't say take homotherty from Q. Project back from Q onto the line. What is this homotherty and all?
No, we
Project it from
have to use.
Q. Yeah,
Yeah,
we'll
homotherty
write this,
from
bhai. We'll
Q.
write this. Yeah,
Wait,
Homotherty. No,
it's
no, no.
not homotherty.
No,
It's
no, no.
projection.
How to write? Wait, how to write homotherty? Wait. Listen. This H Q. Okay, with ratio 1/2. Sending TM to H. Okay.
Yeah.
Wait. Call this function delta. Delta. Then delta
Okay,
send
we
K
had
to
delta.
H.
Bhai, use epsilon. Use epsilon. Use epsilon. We had delta. We had delta.
Okay. Use epsilon.
Yeah.
So
Use
good.
epsilon. We had delta. Okay. Yeah,
Okay,
that
wait. So
finishes.
okay, I now I respect it. This was good. This was good problem.
So now we
That was
respect.
trick bash easy.
Oh yeah.
Yeah, and
That's pretty nice.
Yeah, it's not trivial
Reflex
trick match. Luckily.
Okay, I will
Okay, we took
explain.
only 3 fake
I
solves to
will.
complete the problem. Wait, I think the least time we took in
Yeah, it's okay.
P3, then like P2 and
I thought this will take like 3 minutes.
bro, 8 people are still watching us. Wait, 8 people are still watching us. Like, okay, we actually have like a good fan following. Like 8 people are still
In the middle,
watching
it was
us.
3
Please.
sometimes.
They might regret it. Atharva, we fake solve Geo 3 times.
That I saw that, yes. I was
Yes.
there.
It only took us like 3 fake attempts to like complete the problem.
So we're done now.
That is like not much. Yeah.
Yeah, I will just explain this
Yeah,
question.
next.
I will just
Nice.
explain.
Okay, I'll end the live stream now.
Yeah. Oh, wait. Who will end the live stream?
I can.
Wait, okay, wait. I'll explain then. Okay, there's nothing to explain, guys. Believe me. B, C, M. I have to write up so many things. R, C2, A. Okay. First notice that like just go rewind, watch, and like just note T is not equal to O. Okay, T is not a center. Just believe that fact. So now
Yeah.
what we apparently having is T is like intersection of these things, like perpendicular bisector and QM. Uh, why why this is true? Because wait, why we want this? Oh,
Wait,
because
what?
HM will intersect either at A dash like antipode or Q, and like for T to lie on perpendicular bisector, it has to be the center or this intersection. But just rewind and see like T is not a center, so T has to be this. And now we want to prove is that T is a T lie on permanent bisector of B2C2. Okay. Now notice that by angle change, like this is angle C and this is angle C and this is perpendicular bisector because consider circle passing through center at M passing through B, C1, B2C.
I think
We
you
get this is also angle C.
should slow down a little. You are like at bullet train speed. Slow down a little. It's okay. Like we are not ending the stream before you touch the problem.
Okay, B,
Yeah,
C1,
go on.
B1, C are cyclic with center M. So B2 lie on perpendicular bisector of B1, C1. So B2B equal to B2, C1. And like, yeah, this is basically by definition. And because we know angle, this angle is angle C, which is this angle, if you can see, cannot see, that's also this is, and because of perpendicular bisectorality, this angle is also C. And because of that, we have B2B a tangent, like, call it tangent to an ABC.
Wait, we never used the fact that
Okay,
it's the tangent. Like we never used
never
that.
mind. Like we just state it for no reason at all. Now notice that like okay, notice that if you call it CC1 is parallel to MB1, B2, and BB1 is parallel to MC2. So like if you consider this intersection, HM cap intersection of B1 C1, which is very great intersection, Y, then notice that Y is the center of homosity, which send this triangle to like this other triangle because triangle HB1C1 to because like this parallel condition holds and HMY are collinear. Okay, because that's how we define Y. So now we have this thing homotheity. Now notice that like if you want to prove like T lie on like perpendicular bisector, I will just call like P, like this. If T lie on perpendicular bisector of B to C2, then whatever like suppose with like advanced term that in this homotheity T will go to N. Okay, like suppose N will go to T. Then what we want to prove is N lie on perpendicular bisector of B1 C1. If you in short like okay look this should lie on perpendicular bisector, then if you consider the same homotheity which will send this to N, then we want to prove this lie on perpendicular bisector of B1 C1 because it's just homotheity from Y. Okay, now notice that by definition of T, Tm is parallel to AH, and so as a M go to H, Tn has so no not Tn, NH should be parallel to Tm because like it's just homotheity, descending homotheity from Y, and that implies that N lie on AH. So this point lie on AH, and we want to prove it's like lie perpendicular bisector of B1 C1. But you can notice that like if N lie on perpendicular bisector of B1 C1, then N is the center. Basically, we want to prove N is the center of A Q C1 H B2 with AH is diameter. Okay. Now key observation is like you do harmonic, and it's well known that like if this is T and this is like suppose uh, I don't know like W, then like because of this harmonic
You
quadratic
should
we have like A
prove why that is true.
A
Wait. I think you should prove why that is like that cross ratio is made.
no no wait
You are
AWHD
proving.
is
Sorry. Go on.
yeah yes now if you call like R is equal
No,
to
that is
like
well known. That is well known. Sorry. Yes.
yeah if you call R is equal to B1 C1, then you just like project this cross ratio. Yeah, that's not like obvious to see. Uh, then okay, then notice like it's well known that R also lie on the QA because of radical axis. So this will send to Q. H will go to H because H likes H. Y W will go to Y and D will go to M. So now we get like this interesting cross ratio is equal to -1. Now from here we do another projection. We project this ym from n onto the line. What line is this? Tm. So q will go to some point k. For now, like consider point k. This will go to infinity along ah. So like basically perpendicular to bc. Y will go to t and m will go to m. So we get this is also -1. So if you call this point k, then we get like k is the midpoint of tm, because like we have infinity this cross ratio -1 because of cross ratio facts. Now you define a homothety center at q, which send ah to tm, right? Yes. Now note that this is parallel, so this homothety is defined, and as a k is the midpoint of like k is the midpoint of tm, we get like whatever, like n is the image of k because of collinearity in this homothety. We get like n is also midpoint of ah.
Yeah.
And as a ah is a diameter, we get n is the center of the circle, and that's why it's lie on perpendicular bisector of b1 c1. That's why t also lie on perpendicular bisector of b2 c2. And that proves like T is indeed the intersection of like permanent bisector of BC and B1 C2, which also lie on AQ, and we are done.
Yeah. Nice.
Yes.
Wait, someone has questions.
Very awesome.
Okay, if you have questions, you can ask in the comment
Wait,
section.
does
This is problem
someone?
6.
Yeah.
I don't know. Like people are in comments and
Yes.
checking comments.
Wait, should we rate the problems? Actually,
Oh yeah. I
rate
think
them
we
like
should
bad.
try.
So wait, man, we should rate some kind of what do you call this first problem? Like very bad.
First problem. First problem is algebra. Certain.
Yeah, it's algebra inequality, and like it
Oh,
should be the hardest.
it's like a good problem. I would say it's a good. It's not.
I feel like it was a bit hard.
It's very easy to get caught up in fake solve, like the
Yes,
4 to
yes.
n minus 1 thing.
Oh yeah, it's very easy to fix. So that's
I
also
mean, I would argue that P1 is the hardest problem.
Like this is like probably like 20 moles at least.
yeah. I think this can be put in as a P3 also. We just
Yeah, I mean, compared to the P3 that we had, it's definitely harder.
okay.
Yes.
This P2 was okay. Like this P2 level,
Yeah,
and it's like
exactly.
kind of hard to come up with the F, like and the cyclicity.
Yes, yes.
Yeah.
P2
And
is hard.
I think like people also bash this. Like wait. I know people MMP this. This is Manda. This was
What?
MMP problem. Okay.
Ah,
Yeah,
interesting.
Shreya
Wait, how do you
MMP this.
MP this? What? Wait, you MP
Yeah.
this? That's interesting.
I have no clue.
That's actually
Just
crazy.
for your curiosity. Okay, P3, I like the
I
P3.
am very
Like,
curious
okay,
about
like
this one.
it's not actually
P3 is like 10 moles, like not
P3 like come up with the solution is fine, but like no, but like how you write up, like writing up like this fact, like you have to use all of the terms. I guess like it required like much more detail. Like
I guess the write-up is
because
like
like
harder than the problem itself. Like,
yeah, I mean like the main idea was like you can change first few numbers and like amount of time like second last and third last term, and then like the after that fact you have to write some like vigorously like why everything has to be worked out. I think like this writer is good. But problem was nice one. I feel like
Yeah.
it's like
The
people,
problem was nice. I agree. P3 was a good problem. P4 was also a good problem.
yeah, people are also. I mean, okay, it's fit the position of people as a like binary search. Like you know the thing, but like you still have to cover up. And yeah, binary search was also awesome.
I think we just cooked for a long
Yeah, I
time.
like.
Like, it was quite easy.
Yeah, we kind of cooked for a little bit, but yeah, it was nice problem. It's P4 level. Oh, P5 was so awesome. I mean,
P5 was,
I
I
think
think,
day
my
two was
favorite
awesome.
problem. P5
Yeah,
was my
I
favorite problem of
think
the test.
day 2 was very awesome. You
Yeah.
can put this as P3 also. P6.
P1 was good.
Like, it's still fine. I guess.
Yes, yes.
This one was
I
nice.
agree. I
And
agree.
And P6 was also nice. Like P6 was also hard problem. I don't think like coming up with like
P6 was good.
one homotherapy and second
And
homotherapy.
that process is very hard.
Yeah. Yeah, day 4 was general like. Yeah. This was hard one actually. I agree.
Yeah, P2 is actually okay. Day 2 is actually hard problem. P6 is very hard.
Yeah, day 2 hard.
Okay,
Day 1
complex bashing, this might be a different argument.
yeah, so true.
Wait, no, complex bashing, this could be like a possibility. Like, I don't know. I think P6 can be complex bashed. After finding the homotherapy, it is certainly complex bashing.
Any problem can be complex bashed if you bash harder.
Okay, after finding homotherapy and showing that it's not the center.
Well, like
What?
if you're going to find such a hard homotherapy anyway, then
Oh,
like
yeah,
why
wait.
yeah.
Wait, the homotherapy I think is
Fine, then,
relatively
I guess
easier
you
to
can.
find because of the parallel lines.
Yeah.
Okay, I think we can.
I thought
Okay,
this
I don't think
triangle,
anyone
like,
has any.
yeah, okay.
I don't think anyone has any questions. So
Should we end?
nice. No, I don't know. Okay, no one has questions. We can end the stream.